Good morning. Thank you, everyone, to come. It's a great pleasure for us that we have everyone here participate in person, of course. Everyone here, you are very, very welcome. And the people that are remotely, thank you for attending the 7th workshop on data science. Just a little bit introduce about this workshop. The workshop aims to promote the dissemination of knowledge and the exchange of experience on science and open data among researchers and researchers from Brazil and other countries' professionals. In this 7th edition of a workshop on data science, the mission of this event is to promote a close collaboration between Oak Ridge National Laboratory, connected with the Department of Energy of the US, the global community of data sharing, DataCite, and the Big Data Research Group from USP and Instituto Nacional de Pesquisas Espaciais, INPE, that will present in this workshop a Brazil cyber infrastructure to manage observational and modeling data that is focused on atmospheric phenomena to Brazilian scientific academic in the Amazon. To start this 7th workshop, I would like to invite Professor Gilberto Francisca Marta de Souza to make the open section. Thank you, Professor Gilberto, to representative of Director of Escola Politécnica, please. I would like to invite Professor Jorge Hadi, the head of Department of Computer Science, Computer Engineering of Escola Politécnica. Thank you, Professor Jorge. And I'd like to invite Professor Eduardo de Rezende Francisco, the coordinator of Data Science Group of Fundação Getúlio Vargas from here, from Brazil. Thank you. Thank you, Professor Eduardo. Thank you very much. So, now please feel free to sit. I'd like to make some short words. Maybe, Eduardo, could you start, please? Make some words, if you want. Feel free. Is that working?
Me first. Okay, thank you very much for the opportunity here, Professor Pedro. I'm Eduardo de Rezende Francisco from Fundação Getúlio Vargas, the School of Administration, Business School of São Paulo. I'm here with Professor Elia Matsumoto from School of the Economics. It's a pleasure and an honor for us to be here. The data science and big data and artificial intelligence are strategic issues for us. We have two main events. One in the first semester, that is the Tech Day in May. And we have the Encontro Brasileiro de Data Science, that is in the 5th edition, that is promoted by School of Economics, Professor Elia. That was in the last September. And Professor Pedro was one of our keynote speakers. And it's a pleasure for us to be here. Thank you very much.
Thank you, Professor Eduardo. Thank you very much to attend our workshop. Thank you very much. Professor Jorge Hadi, please feel free to make some.
Okay.
Thank you.
Good morning to all of you. And I have only few words to thank you by the presence and to desire you a good good workshop, and we are here to to help all of you. That's all.
Thank you very much, Professor Jorge Adi. And now I'd like to invite Professor Gilberto Francisco Marta de Souza, the representative of head of Escola Politécnica, one supporter of this event, and he is the head of research commission of a Polytechnic school. Thank you, Professor Marta.
Thank you very much, Professor Pedro. First of all, welcome everybody to Escola Politécnica, one of the 5 engineering schools of our University of São Paulo, but it's the oldest one and the one with the biggest number of students and biggest number of engineering courses also. It's a great pleasure to have this event at Escola Politécnica. Welcome our researchers from Brazil and from US to stay with us for 2 days, and we hope that will be a very interesting event with a lot of changing of experience regarding data science. For University of São Paulo also, this event is very important. Once University of São Paulo is working with open science, we're trying to disseminate the concept of open science, and open data is a very important concept inside open science. And also we are developing a repository of open data regarding the research developed by many of our students and our faculties. So this will be a great opportunity to understand some of the experience that the researchers are taking with this kind of open data and open science. So I don't want to speak too much, and thank you very much again for your presence, and I hope you a pleasant stay at São Paulo and at our University and Engineering School. Thank you very much, Professor Pedro.
Thank you, Professor Gilberto. Thank you very much for all attendees here in the table. Thank you very much, guys. We are used. Thank you. Thank you, Jorge. Thank you. Obrigado, Jorge. Obrigado, obrigado. Obrigado, Gilberto. Obrigado. Now, we are going to start the workshop. We have very nice presentations here today. Today we have, in the morning, we're talking about the infrastructure, how you provide the infrastructure for open science. So you have first a presentation of Gir Prakash. Gir Prakash will give some experience about how Oak Ridge National Laboratory, the specific program from DOE, Department of Energy in US, that work with collect atmospheric data in all the world. So Gir is give us so nice experience about this. After that, we have opportunity of DataCite to talk with us. DataCite is one of the supporters of this event, this workshop, and that DataCite is one that intermediated the grant that we received this year from Zuckerberg Fund that support this infrastructure that I will talk after. We are releasing here at the university. This is a collaboration between University of São Paulo, INPE, and Unicamp. And you are going to provide a very nice infrastructure here to support atmospheric data. So I will talk a little bit about this. At the end of the section of this morning, we have a table to discuss. We have questions to discuss about open science, about infrastructure, about the DataCite, about the ARM. So you have opportunity to make some questions. We have people to participate in online. You can make some questions. We have some students to get the questions that you can make questions about in the chat, in the YouTube chat. So during the round table that you are going to have here, you can make some questions for the presenters. This is the program of this morning. During the afternoon, you are talking about the data curation, data quality. This is very important because we don't need to have bad data. You don't need to publish bad data. We need to publish good data. We are talking about this, about data quality, about data curation, and how you can provide this. So we have 3 nice presentations during the afternoon. We have a presentation from Paulo Artacho, Professor Paulo Artacho. Professor Paulo Artacho, you talking about the demanding of support atmospheric data in Amazon, and talking about how you have a lot of problems related with this. You're talking about the LBA. This is a long-term program that collects data in Amazon for more than 30 years, I believe it. We have 10 towers in Amazon, so nice project. They have campaigns to collect. And of course, Oak Ridge Army participated in Go Amazon 10 years ago, Gear? Yes, 10 years ago. And we have some nice collaboration between Oak Ridge National Laboratory with Professor Paulo Artacho. So Paulo Artacho will talking about this. After, you have a very nice presentation of Davi Coppola. Davi Coppola is professor from Unicamp and the coordinator of a very nice project in Amazon, the Amazon Face. Davi is here, and he's talking about the demanding of data management, demanding of this project that you are collecting for long term in Amazon. And we have very nice presentation. Thank you very much, David, to come here. And after, we have other presentation of Michael of Oak Ridge National Laboratory about the data quality. So, discussing about demanding, after, you're talking about how you provide data quality, how you can provide data quality for data curation. So, this is the question, good question, that we make to Michael to talk about this from Oak Ridge National Laboratory. At the end section this afternoon, you have a round table to make questions. You can make questions with people that are here, of course. We are going to make questions, and you can make questions from YouTube too, in the chat of YouTube. So, thank you very much again. We are going to start the first presentation now. Oh, just talk, it's important to say. We'll have a short break for people that are here. You have opportunity to make some discussion, and during the morning, during the afternoon, you have a short breaks here for coffee break. Everyone that are here is invited to be part of this workshop. Thank you, this coffee break. Thank you very much. So we are going to start the first presentation. I will introduce Gir Prakash from Oak Ridge National Laboratory. Gir serves as a director for the U.S. Department of Energy Atmospheric Radiation Measurement Facility. This is a program of DOE department. He is the coordinator, the head of the data center located at the Oak Ridge National Laboratory in Oak Ridge, Tennessee. In this position, Gir is responsible for the leadership and management, the ARM data center, and the site data systems, whose primary focus is on product delivery, which includes operations and engineering necessary to sustainable and advance excellence in the data management field. Especially the ARM data center currently serves over 1.8 petabytes, I don't know, maybe is more, I think so. Gear will update us about the 11,000 diverse observational data products that included observing that you have collected data in Manaus, Manacapuru, 8 years ago or more, maybe, the Go Amazon project. GEAR leads the development and execution of multi-year plans that adapted next generation of computer architecture to increasing demands of data volume, rates, complexity, and challenges of high-resolution modeling. GEAR has over 30 years of experience in science data management and discovery metadata and data interoperability, data citation, computer as a service, web services, and visualization. Thank you very much, GEAR, to attend. Thank you. Please start your presentation.
Bon dia. Good morning. So yeah, Pedro, you got a really good memory. So we started this workshop, I don't know, 10 years ago or more than 10 years ago. So the very first data volume was 1.8. Now ARM has 7.2 petabytes. So as of this month, we have 7.2 petabytes of data. Yeah. Oh, thank you. Yeah, I was going to ask you. Okay, so a little bit background. So Pedro and many of us from the US, we have been working on data management for over a decade now. And these are some good memories. So Pedro was there at Oak Ridge National Lab. This was probably like 10 years ago. And this car was, it's a 3D printed car. Okay, it's a functioning 3D printed car, and Pedro wanted to bring it here, right? Yeah. And this was the last workshop that we came here before COVID, just before COVID. And we had a really nice discussion with Dr. Susie Allard from University of Tennessee, and Marcelo, and then Mike Frame from USGS. So we always had this collaboration going for quite a few time, and we get a lot of students from USP to Oak Ridge for internships. Okay, so we always appreciate it. We had like really good superstars came from Pedro's team here, and they made huge impact. And Michael can talk about all this time, all these interactions that we had. Yeah, yeah. So yeah. And Pedro visiting the ARM data center, and he's also presenting the work at one of the Department of Energy's science team meeting. So, yeah. Okay, so a little bit about the ARM program. So ARM stands for Atmospheric Radiation Measurement, ARM. It's a national user facility managed by 9 different labs. It's not like one lab that manages this entire entire facility. So it's a distributed, both managing as well as where we deploy the instruments. So we have over 500 really complex instrument sets, and that measures anything on the atmosphere and all the way to the near surface. So what do we do? We primarily study the cloud life cycle and the aerosol life cycle, and then the radiation budget and how these 3 impacts the precipitation and so on. Okay, so we have started this program back in 1992. So we celebrated our 30th anniversary 2 years ago. So now we are in 32 years of continuous operation. So we have three major ground observations, and we have three mobile platforms that we take it to different places on the Earth, which I'm going to talk about in my next slide. And we have very complex set of radars, and then more recently we have started the high-resolution modeling activity for the observational sites that we have been collecting data for 30 years. So this is like an important aspect. Pedro, you touched the importance of data management. So whatever we collect today, it needs to serve the science 30 years from now. Okay, how do we do that? We have to have a robust data management practices. Okay, so that I cannot stress of more enough the importance of data management practice, but I will give you throughout my presentation why we need this. And it is not, it's not very complex. This may look like a very daunting, but I mean, there are data management experts here. Pedro, he has been in the scientific data management for over 3 decades now. Yeah. Okay, so some of the recent deployments, I just wanted to throw in few photos here. And so this one is our recent deployment in Tasmania, Australia. And we have been operational in the last few months. And it's really in a place where, I mean, it's in the middle of nowhere, basically. So we have really good collaboration with the Australian CSIRO, Bureau of Science Agency. And then this one is much more recent, and we just made it operational. So this is in Alabama, Bankhead National Forest area, where we deployed our mobile facility number 3 in there, and it's just made it operational 2 weeks ago, right, Michael? Yeah. So we are always moving. We are always going to new places. So we were here in Manaus and Manakapuru back in 2015. So yeah, we did really good collaboration with a lot of folks here, and we have really good data that we collected, and it is still available to the users freely around the world. Right? And we also have an aircraft facility, and we have both manned and unmanned aircraft that we fly within our deployment. And then, like here, we actually flew between Manaus and Manakapuru quite a few times to study the aerosol impacts. So back in 2020, we actually were part of a 20-country collaboration called Mosaic. It's a drifting exercise. We actually put a lot of our instruments on top of an icebreaker, and we sailed to the Arctic, and then we let the ship freeze there and get it drift over the months. A very fascinating expedition, and we got really good data from there. And all of these data are currently available through the ARM Data Center. And this one, that's me checking the Norway site that we had on parallel with the ship deployment. Okay, so just to give you a glance, sorry, the graphics are not clear, but back in 1992 is when we started, and then 96 we reached our first terabyte of data, and I still have that disk. It's the big optical disk, and I still have it, and of course the data has been migrated to newer architecture. And 2002 is when I started with ARM, and it was about 20 terabytes. That was a huge, big data. And 2010, we grew to 200 terabytes. And then 2016, I still remember during Christmas time, we reached our first petabyte, and then we keep going. Right now, we have 7.2 petabytes of data. Yeah. And so these are all the places that we, our users are from. And just last year alone, people from 34 countries downloaded the data. So I'm explaining this because like you have to have a good data, good quality data. So people will come and use it for their science. So just last year alone, we have 1,400, more than 1,400 publications, and that includes abstracts, presentations, and journal articles. So it's a very, very highly impactful science. Okay, so now go into the ARM Data Center and also the ARM Data Services. So we have quite a few end-to-end data and computing ecosystem that continue our data operations from whether instrument is functioning and whether it is producing data, and we have advanced data collection systems, and we have a really robust computing, high-performance computing, and then we have comprehensive data processing capability, and we also spend a lot of time in data interoperability. So it doesn't mean that like if I collect the data, that will be automatically used by users from all those 34 countries. You have to spend time in making the data understandable by others or other programs. So we use FAIR standards, and we have a robust citation strategy, which I will be talking about it. And more recently, Michael and our team at Oak Ridge, we have started implementing many AIs, not only to give our data to AI, scientific AI, but actually like use AI to improve the data operations, data management, which I'll be talking about that. Okay, so very briefly, so all these on the top are our sites. We have one in Southern Great Plains, Oklahoma, USA. Then we have one in Azores. It's a small Portuguese island. And then we have one in North Slope of Alaska. And we have 3 mobile facilities and aerial measurements. And we have PIs. They conduct hundreds of field campaigns in a given year using all these instrumentations that we have. So all this data flow through a site data system. So every site we have a site data system, a rack of instrument computing that monitors the instrument, that collects the data, and then securely transfer the data to the ARM data center, which is located at Oak Ridge National Laboratory. Okay. So when the data comes in to Oak Ridge, we go through data quality operations. The very first one we do is data ingest, and then create different data processed levels of data. And then we apply metadata, because like metadata is what tells the data and its usefulness. And so we also have operations that generates higher level scientific data products. And we have a robust computing cluster, and all this data gets archived and then distributed to users around the world for free. All this happens within 24 to 48 hours after collecting that data. So that's the commitment that we try to give. And of course, like there are some cases where we don't have enough network, which we have to wait for the data to arrive to the Oak Ridge. But that's getting better and better thanks to all the satellite technologies that we have currently. Okay, all right. Okay, so once the data comes in, as I said, like within ARM Data Center, we have a robust infrastructure that does all these different operations. When the data comes in through our doorstep, it goes through the daily ingest creation, and then it actually goes through various activities, QA check, and the value-added product generation, and then we actually have few cases where we have to provide the data near real time to our users. For example, like the weather prediction models, they need the data within 15 minutes of collecting the data, so that like they can say, oh, okay, so we can deploy this balloon based sounding system or not. So they use it for operational activities also. And we spend a lot of time, thanks to our data quality office from University of Oklahoma. They spend a lot of time in assessing the data quality. Everything happens within a day. So we can't do it all manually, okay? So that's where the tools that we have developed over the years, helping us to find the anomalies of a data and then get the subject matter expert to quickly review and flag it. And which Michael is going to talk quite a bit on how we do the data quality in a semi-automated manner. Okay, so I talked about the site data system, and it's just one rack of computer, if that's what you want to think about it, right? It has some storage, some processing, and network that connects all the sensors to the centralized site data system, and from there it securely transfers the data. But you can think like program like ARM. We have been deploying the campaigns throughout the world, from Arctic to Antarctic and anywhere in between, on top of a ship. So this needs to be really strong and also scalable. So we have done many of these deployment, and we have hardware and software solutions to pretty much conduct field campaign anywhere in the world. I say that very humbly. Yeah. So we also continue to upgrade these. For example, like we have lots of use cases for edge computing, for near real-time computing, where the instrument is functioning. So the AI activities, so all these things. And then we keep adding our network connectivities via the ISP, and then the 5G and the satellite solutions. We got like quite a few Starlinks, all those things. Like if we don't have a ISP, we look for 5G. If we don't have 5G, and we look for other options like satellite too. All of this sends the data to Oak Ridge. Okay, so I want to talk about the importance of metadata. So metadata, most of you are familiar with FAIR, right? Findable, accessible, interoperable, and reusable. We address FAIR by beginning with like spending really quality time in preparing metadata, rich set of metadata for each of our data sets. And so these data sets, this metadata contains every detail a scientist would typically want to see before they can use the data. So this is the number one priority, and that's how I can proudly say like people from around the world take our data and use it with minimal to very no manual guidance from us. So everything is self-described. And we have over 11,000, actually over 15,000 data products now, and closer to 500 instruments. And so every day we receive about, on an average, about 3,000 data streams to Oak Ridge every day. So think about if we have to do it manually, how much do we have to do? So all these sensors that you're all building, I was talking to a few of you about the phase experiment. You have so many hundreds of instruments, and think about how you're going to manage the data. So, we simply cannot do it manually. So we have tried it in the past, and but that time we couldn't get the networks and all from Manakaparu. We had to go and fetch the disk and then bring it to Manaus and then send it from Manaus to Oak Ridge. So we had so much challenges. Now, thanks to all the networking connectivity available, so we could, these are like totally automated now. So with that many data streams, and how would the user typically come and find what they want? Again, really robust metadata, but also we created something called data epoch, where like if there is a storm and users want to study about the storm, or if there is a climate event like hurricane or whatever, they wanted to study about that. So we create these epochs and highlight it within our data discovery. And also we created recommendations. Not me and Michael, it's actually the subject matter experts who said, okay, so out of all these atmospheric carbon measurements, these are the high quality ones, and these are the ones that we recommend. So we provide recommendations just like your favorite shopping, online shopping portal, right? Okay, so instrument metadata. So instrument metadata is so critical, and that goes from all the way what version of instrument you are using, what type of calibration that you are using, and every detail about that instrument is extremely important. And we make that available within our data search. You're all welcome to go to arm.gov/data and give it a try. It allows you to just search for any atmospheric keyword and any the instrument name. So we will show you the matched ones, and both spatially as well as temporarily. And for newer users, we actually ask them a few questions. What are you interested in? I say aerosols, and then we keep asking questions, and then we give the answer, and then give, okay, here are the data sets that we think you are interested in. So that's a guided search. So we provide variety of data discovery things. And again, I want to pause here for a minute. This is very important for users. This is how the users are finding the data, and what we collected so far in the last 32 years or so. And last summer, Pedro student, Rosa, I don't know if she is here, but she was there at Oak Ridge, and she learned about the software, how we make the data discovery, and Pedro is implementing a data discovery very similar to the ARM data discovery. So he was able to send a couple of interns and then get the knowledge on how to build a system like this for users to find and download the data. And here is another screenshot of like how you can drill down to the data, and then all this metadata about that instrument. This timeline shows how long we have been collecting data, and all those like little lines shows there is a problem with the data quality, and thanks to our data quality office. And when users click one of those, they will be able to see what the problem during that day or during that week. And they can actually look at the plots, and they can if they have questions, here are all the actual experts that they can, with one click, they can connect with the expert, and they can ask the question, hey, I have a question about this data or this variable, and give me some more detail. So we provide as much detail as possible to the users in a very organized way. And there is Jose. So this is the data quality report. When you click on those bars, it shows, there is a problem in that day, the sensor was failing, or the network was down, or anything. So you actually get to see the data quality report. And when the user gets into the data, they know what they want, and we present variety of options to download the data through FTP, or larger data through Globus, or we are working on making the data available via the S3 protocol. So the things typically scientists use to download the data. So we provide all of those, all those details. Okay, again, like we build this data discovery with the help of quite a few people, and I want to call out University of Tennessee's usability lab. Dr. Susie Allard and her team helped us quite a bit in terms of doing usability analysis of our tool. If you go to the data discovery, it is all highly vetted by usability team, and that's how we make it very user-friendly. There. Okay, so on the data computing side, ARM Data Center uses a variety of computing resources. We have our own data center that handles these 3,000 plus data streams every day, and process those, and archiving, and then distributing to the users. But also we have high performance computing, very dedicated one called Cumulus, the name of the cloud. So we have about 16,000 cores in that high performance computing, and it's used by our large scale data processing like radar data processing, but also modeling, high resolution modeling operations, and then the value added product generation, as well as PIs or scientists from around the world. They can say, I want to use ARM data, and my research heavily relies on ARM data plus other data, and I want to have computing power, give me access to that. And so we do that through Jupyter Notebook and variety of means. So they can make use of the high performance computing, and everything is stored in a robust storage architecture, GPFS, General Parallel File Server, and we are leveraging the ORNL's leadership computing for these high performance computing activities. And all the data are actually saved on offsite also. So we can't afford to lose the data. Simply, we cannot go back in time to measure. We don't have that technology yet, right? Yeah. Okay, so all these are traditional. So what do we do now? So we have been working on enabling a concept called data workbench. So if you stop and think, we have 30 plus years of data, and we have 30 plus years of software that we have been working on for operationals and also users. And then we have a very, very scalable computing. So all these three major resources, we are making them in a unified ecosystem for users to come and not just find the data, but then stage the data, and then use our software freely available on that workbench, and they can do their data analysis all from their comfort of their home, but actually leveraging our computing infrastructure, the data, so they can also bring in additional data, for example, satellite data products or other data that are freely available from other portals. They can bring everything into this workbench, and then they can do the analysis, and then they can publish it with assigning DOIs, and then they can write a paper and reference it, and we really provide, our vision is to provide the entire data experience to our users using a unified ecosystem. And I want to happily say that we have released our phase 1 of Data Workbench earlier this year, and Michael and others are working really hard to get the second version sometime next month. Yeah. And Michael will be talking about the Jupyter Notebook available today. So the Jupyter Notebook, for every data that we have on the data discovery, we allow users to download the data or stage it in Jupyter Notebook, and then Jupyter Hub, and then we provide a sample Jupyter Notebook. And that sample Jupyter Notebook is actually a collaboration from Dr. Pedro's team. And who are all in that Jupyter Notebook building activity from interns? Yeah. Felipe? Yeah. Yeah, Josa, Felipe, they all actually helped us create this sample Jupyter Notebook. So if you go and download the data, we actually provide, hey, you want a sample Jupyter Notebook that you can begin with? And that actually allows you to read the data that you just wanted to download and use it, and then like visualize it all like with one click. And then you can modify and use it. And thanks to Pedro's team here. Okay, so here's another, so as a facility, we have to provide lots of operational tools to help with operating instruments. And for example, I mean, like you talk about LBA or the current phase. So you have so many instruments, and you need to check the health and status of the instrument, and you need to make a note if there is any problem with that instrument, and then have the team to look at it. Oh, there is this problem. We should look at it more, or look at the plots and so on. So we last year. We actually, 2 years ago, we developed a new tool called Field Campaign Notebook. And we have been creating this notebook for every campaign. I highly encourage people who are actually doing the sensor deployments to look at the Field Campaign Notebook. And this is one of the kind. And when we wanted to have a notebook like this, we couldn't find anything in the world, so we had to create one, and we created in a way that it can be highly scaled and highly deployable to any field campaigns or any experiments. This allows the team, the science team or operational team, to provide daily reports and look at the plots generated from the instruments real time, and then the local satellite imagery and other real-time data for that specific area. So it's really for site operations, instrument operations. And we have done it for, like we started with a couple of deployments, but we have over 7 field campaign dashboards currently available. And I'd be happy to talk about that and show you how this could be purpose. We are in the process of making this as an open source so that like any project can download and customize it for their operational needs. Okay, I briefly mentioned about AI. So all of our data is getting used by many AI-based use cases. But we are also using AI to improve our data operations. And for example, enabling edge computing on our sites, the instrument computers, and the data quality analysis using AI. And we are working on providing recommendations based on AI. And how do we do that? Basically, when the user logs into the ARM data discovery, we know their ArcID. We go to the ArcID API and fetch their publications and so on. And now we know what their interest is, and then we actually look at like others who are doing the similar research, and then we can give them recommendations. they won't even realize it's going through this, but like they will see, oh, you have this data also? I want that. So it's not random. It's actually connecting your ORCID and your publications, and then like the relevancy and all those things. So we are using that to provide recommendations, and also we are in the process of making the data available through the cloud services like S3 protocol and so on. So again, for the projects that are kickstarting now, including the phase, think about from day one. We need rich set of metadata, and we have a really clear standard for file naming. That is so important, and I can guarantee you can go to the ARM and you can find the very first data that we developed, and it is following the same structure as the data that we collect today. So always start with the site, and then instrument name and what data level, and then this is the file naming standard that we deployed, and we have been we have been refining it a little bit, but we always go back and reprocess and rename the historical data. So everything is in this format. So importance of following a standard. And so DOIs are assigned at the instruments and data level. And so anyone getting the data, we also provide DOI as part of that, and that is assigned at this level. And I will get into that in a minute. So ARM data citation. So we worked closely with OSTI, the Office of Science and Technology Infrastructure by DOE, and DataCite, very closely collaborated DataCite many years ago to enable a DOI citation architecture for continuously growing data. So our data is being measured from our instruments every day. And so the data grows every day, the same data. So we have to create our own strategy, citation strategy for continuous data streams. And we seeked help from DataCite and a lot of publishers, and then we developed this architecture for users to seamlessly download the citation. That includes the DOI. And you think about it, right? Like an instrument is managed by a set of people, and the data is created by a set of people. Everybody who spends their time and effort need to be credited. And we make sure we create DOI and then add all of them as authors. And that's how we make sure they get the data citation for all the hard work that they do. And so we expose the DOI data citation in many places. As like there's like, if we just do it in one place, people will miss it. So we continuously encourage people by providing the citation in multiple places within our program. And so we are currently working on improving. The data citation is still evolving. I did the very first DOI implementation back in 2012, and since then we have been improving it based on the community input, and we just recently got our nested DOI. Basically, if I am taking the data from, as a user, if I take the data from ARM and from NP or from USB and many places, then like when I create a data product using all these sources, all these source data streams and the people who were in charge of developing those need to be credited. So thanks to DataCite for enabling this nested DOI, hierarchical DOI. So we were able to do that. And also we are working on time-based author credits, because like programs like ARM, 32 years history, people in charge of that instrument maintenance, they change over the time. And we need to make sure everybody gets proper credits. And we are currently working on time-based author credits. So again, we are we are and we will be continue to work with broader scientific data community. So anything that you have seen so far, it's not just like we came up with an idea and we just developed it. No, it's not that. It's actually it's the result of working with broader community. So we have, over the years, we have like over a dozen of data intensive projects, and they are working groups and international and national working groups. So we participate in on all those things, and then we actually adopt those standards. And thanks to that, we not only provide our data available through ARM portal, but there are many other data centers and data portals. They have similar climate data, and they actually can take our metadata all programmatically and then ingest or index in their search interface and make ARM data available through their portal. For example, like Pedro, like your data, Atmospheric Data Center Discovery portal can link ARM data, and the users can actually find the data. But when they want to download it, they'll be given an API or a link to go to the actual data. But they can read about all about the ARM data using within the portal. So here is the Mosaic data portal where I was telling you there are like 20 countries participated in this expedition, and the actual portal lives in Europe. And we provide our metadata to them, and you can actually search ARM data on their portal, and then you can click and download data using the ARM. So similarly, we also bring in metadata from other projects. For example, like this is a next generation ecological experiment data portal. It is nothing to do with ARM, but they have similar metadata, or they have similar data that they collected from Alaska. So we were able to link it from the ARM data discovery. So you can think that way. So this is how we are enabling this data interoperability. So we have done that for many scientifically relevant programs. And here is an example of other data available. There is a smaller, like, expand the search with external repositories. And if I search for soil moisture, for example, it shows not only the ARM collected data, but also the NG collected data. And then they can read about the data from an external data repository, and then the user can choose, oh, I'm interested in, I want to download the data. So they click, and we send them to the external repository. And a couple of more clicks, they will be able to download the data. So it's improving the visibility of relevant data across the data repositories. And okay, so with data, again, like communities is the number one here. We work with multiple communities, and we work and collaborate with NASA, Distributed Active Archive Center, U.S. Geological Surveys, NOAA, NSF. That's not a full list. We with USP and various national and international groups. And we also actively participate and contribute to working groups that's organized by DataCite, Office of Science, Data ID Services, OSTI, and the Core Trust SIL groups, and World Data Center, and CoData, and so on. And okay, these are the examples. Okay, so we we spend a lot of energy in making sure our data management practices follows fairness, and we got our certification by Department of Energy's Public Reusable Repository, and we were certified by Core Trust SIL, and we are currently getting the extension approved. And how many of you are aware of Core Trust SIL? It's the international certification agency by International Science Council, ISC, and it goes through a review process and gives you this certification based on your maturity of the data management. And we are part of the World Data System, and then, of course, OSP. We have a memorandum of understanding, and then we actively involve in CODATA, International Committee on Data, and DataCite, and so on. And this is from the CODATA meeting a few years ago, Pedro, where we met with quite a few people nationally and internationally. So we keep our presence very active in building this network of communities. And that's pretty much it. Yeah. And thank you. Yeah.
Thank you very much, Giri Prakash. We have a very nice experience about this is an excellence of data management, about the data publish, about the data curation. So we are going to stress more about just understand these all facilities, because it's important when you are creating a data repository, you must to have some similar functionality. Of course, you don't have all huge infrastructure, but the functionality is very important. So now you have a very nice presentation too. Next presentation. We invited Arturo Garduño Marganha. Arturo Garduño Marganha, sorry, my Spanish is worst. But his degree in library and information studies from National Autonomous University of Mexico, UNAM. During his study, he founded the Zeta Journal Library Science, which gained significant recognition in the library community across Mexico. Arturo is responsible for All America data site. So thank you so much, Arturo, to come. Please come here. Thank you, Arturo. Arturo, you can use this. I will check your presentation.
The button, the click.
Oh, yeah, okay.
Oh, here it is. Thank you. Can you hear me? Fantastic. Hello, everyone. Bom dia. Thank you so much for having us here. My name is Arturo Garduño Magaña, and I am the Regional Engagement Specialist for Latin America, but sometimes also I'm checking part of the US and Canada, depending on the time zone. And I'm really, really thankful for the opportunity to be here with you all. Special thanks to Professor Dr. Pedro Correa and all the organizing team for preparing this fantastic event for us. So welcome, and thank you so much for inviting us. We are really, really happy to be here. We have seen so far the importance on metadata citation, metadata quality, but how we do enable the discoverability and the citation and, of course, the reuse of the data that we are really, really interested to know more about. Yes? Okay, thank you. Fantastic. So to talk about how we enable this discoverability and the reuse, we have to talk about the persistent identifiers. So probably most of you are really aware of that, but let's bring a very brief overview about the importance and how do the persistent identifiers work. Next, please. Thank you. We know that there are persistent identifiers for many things, but particularly we can identify them for three main categories, which are persistent identifiers, or PIDs for short, people. I'm sure that many of you are very familiar with ORCID ID or ISNI, of course. We also have PIDs for organizations, like the Research Organizations Registry, or ROR for short. And of course, there are also PIDs for things, or in this case, research outputs and resources. That includes DOIs, handles, ISN, ARC, and many more. Next, please. Thank you. Oh, it's fantastic. Thank you. But what is a persistent identifier? It works. It's a special URL that has this alphanumeric string that always refers to a digital resource. It always points to the same resource, and of course at its metadata representation. This is important because with that we can make sure that we always have access, and of course, access to the research outputs. So now, speaking a little bit more about DataCite, for those who doesn't know who we are a nonprofit organization, a global community that shares this common interest that we want to ensure that the research outputs and its resources are openly available and connected so that they can be reused. And of course, to foster the advance of knowledge across between different disciplines. As a community, we want to make sure that we can provide the necessary elements to connect research outputs from samples, physical samples, and images and data sets, of course, to the data and the preprints and the publications, which are like the last elements of the research life cycle. We foster the creation and management of persistent identifiers. We are an DOI registration agency. We provide DOIs for our members. For example, the University of Sao Paulo is a member of DataCite. Many universities and research centers affiliated to the CNPq consortium are also providing DOIs to the research outputs. And we want to integrate different services to improve these research workflows to facilitate the discovery and the reuse of the research output sources, as I mentioned earlier. We are a community governed and sustained by all its members. We work with metadata and code source in an open way. We want to foster also the implementation of open practices. And all of our members also provide this. Of course, the Oak Ridge National Laboratory is also a member of data, as mentioned before. And we want to enable the recognition for a wide range of outputs and resources, not only data or not publications, but as I mentioned before, and we are going to see in the presentation, also physical objects, instruments, code, software, all the elements that are part of the research can be integrated and connected through the persistent identifiers, and we're going to see a little bit more on that. And also we want to, of course, offer and foster the collaboration across the research ecosystem. We are committed to the POSI, which are the Principles of Open Scholarly Infrastructure. And these are our general numbers in terms of our community, where, as you can see, we are working with over 3,000 repositories in more than 50 countries, with now more than 60 million DOIs, functional DOIs. This is also going to be important later in the presentation, because we have recently launched our public data set, public data file, where you can access all these 60 million DOIs entirely. And this is very important for research discoverability and to understand how research is doing in all over the globe. We also think that fostering this drive to cultural change in research cannot be done alone. We understand the importance of working with communities so we can make it normative. We can foster the implementation of these practices, these open practices, but we also need the participation, of course, of the different members of the different levels of organizations, from the universities to the government bodies to the non-profit or non-governmental organizations. So when we work together with this vision, we can foster this culture change where we make it not only normative but also rewarding in terms of incentives. When in Latin America, as you know, one of the main funders for research are the government, the state. So when we understand how we are funding research, we can also provide more incentives to the researchers, to the organizations, and so on. So we believe that this is a practice that needs the participation of all the stakeholders and all the involved parts. And we also have some strategic initiatives, as mentioned before. We really foster the data metrics to help the further implementation and adoption of the responsible data metrics, particularly with the Make Data Count initiative, which has launched recently, only last year it was launched. We also work with other identifier registries like the ROR, mentioned before, to support the community in terms of participating and also financially. Of course, in terms of the rediscovery. Oh, sorry, it's a little bit intermittent, right? But yes, we also want to foster the discovery of repositories by contributing to the development of these repository discovery initiatives like RE3 Data with collaboration and financial support also. So when a repository is registered in RE3 Data, we also are gathering all this information through the metadata to provide more visibility to the research output. I hope you can hear me a little bit better. One of the other programs that we are launching is the Global Access Program. Well, it was launched last year. Right now we are on the second phase of the program. The program was supported by the Chan Zuckerberg Initiative to promote more equity in terms of the global research ecosystem. The idea was to provide to eligible research organizations from low and middle income countries with training, technical support, and of course metadata services to enable to share and discover the research outputs. One of the funding organizations is the University of Sao Paulo with the project, the DataMat project. It's going to be presented later today, I understand. And the idea was to provide that extra support that sometimes the organizations and the project needed to achieve or to be launched in terms of outreach, in terms of infrastructure, or both. And in this case, the DataMap project of the USP is one of the awardees in our first round of the Global Access Program and the Global Access Fund. And that's why we're also very happy to be here in person to meet the people behind the project. It's a fantastic milestone, and we are very proud of seeing the development and of course the launch of this repository. Of course, as mentioned before, the data citation corpus, with the support of different funding organizations like the Wellcome Trust, we recently launched this comprehensive data set of citations to research data. The idea is to address this major issue that known data citations exist in third-party systems, but are not compiled into a comprehensive, publicly accessible corpus that the community can use. So with this public data file, we want to provide the elements and access to the community so they can also help us to understand better how research is done, what elements we should pay attention more, and of course, the impact that research, funded research is having in the different global scale. Now, going back to the technical part, or not so technical, but a little bit more technical part on how we enable this scalability. In terms of the DOI, as you are aware, the structure of the DOI comprises the proxy, which is the DOI system proxy server, is very similar to any URL that you can find, but also a string with a prefix and a suffix that makes the URL unique. And with this specific element of individuality and uniqueness in the URL, we can make sure that it is always accessible, but it is unique and it is always resolvable. And the DOIs are not only comprised by a URL, but also has a lot of components in the back, especially with metadata. In different forms, you can find it either in XML or JSON, but it has a strong element of metadata in the back, so you can ensure not only to have this unique element in the URL, but also to provide a lot of information to the search engines, so you can find a lot of information by the title, by the abstract, by the keywords, by the authors. So that's why it is important to implement these kind of persistent identifiers to research outputs. In terms of the different types of research outputs, as mentioned before, the DataCite DOIs are suitable for almost any kind of research output that you can imagine, but especially works fantastic with research datasets and collections, associated workflows, software, images, instruments, and models, but also in terms of text with great literature such as theses, dissertations, reports, conference papers, technical standards, and any other specification or element that you can find in your institutional repository as the primary publication point is going to work really, really well in terms of the metadata description, and you're going to see this a little bit later. And one also important element that we're working with is the physical samples. Traditionally, the IGSN ID, which is the International Generic Sample Number, is a persistent identifier destined to the physical objects, and from a couple of years now, they have been integrated to DataCite. So IGSN IDs are now functional DOIs that can work, as I mentioned, for individual samples, for aggregation of samples, collection sites, even also destroyed or discarded samples, which is really, really important in terms of the research life cycle to understand the different versions or the different stages of the elements, the physical elements that are also part of our research. So now with the IGSN ID and the integration to the DOI, you can provide information and description to all the elements of the research and also connect all the dots. And this is important because one of the main things that we are want to foster is the metadata connection, to connect all the dots to understand and track the impact, as also Jiri mentioned in the last presentation. About the importance of understanding the track of the research. And how do we connect the research? Well, the metadata schema has some properties. Some of them, as you may imagine, are mandatory, and others are recommended and optional. But with these elements, these 18 elements, you can provide all the necessary description to identify and to provide all the necessary information so that your research output can be identified and can be tracked and accessible in the net. In terms of the different resource types, as you see, you can provide DOIs and also the description for the metadata for almost any research output that you can imagine. In our last version of the metadata schema, which is the version 4.5, which was launched this year, we also provide particular specificities to instruments, so you can track the versions of the instruments, as also presented from the last presentation from Dr. Jiri. clear. And this is really, really important because now we can provide the necessary citation and the correct citation and the correct acknowledgement to the people and that are participating in research, and also on the different stages that we are working with. All this to say that also the connection metadata, it can be represented visually like this. So thanks to all this connection and the use of persistent identifiers, we can identify when a data set with a DOI, of course, is cited by a paper, for example. We also can identify who are or who is the organization that funded this research and provided this research output, who are the people behind the creation of this data set, thanks to the use or implementation of the ORCID ID, and of course also to understand where is the or who is the affiliation from this person. So we can track and identify this map thanks to the use and implementation of particular metadata and particular the persistent identifiers to the people, to the objects, and to the organizations. And we can also track all the map or this this map of metadata that can help us to connect the dots and see who are all the person involved and what is also the impact of our research output, not only in our discipline, but also in different disciplines. That's why we foster these good or best practices to motivate the use of standardized metadata, the use of persistent identifiers in our profiles, the ORCID IDs, the ROR IDs, and of course the DOIs, so we can track and we can represent this map in a much better sense. Some of the properties that we should consider in the technical part for the connection metadata are in the metadata schema with the related identifier to connect with the DOIs and the URLs and the handles, the name identifier for creators and contributors, as mentioned before, with the ORCID IDs or the ROR IDs, the affiliation identifier for the affiliated organizations, and very important also the funder ID for funding organizations that we are using the Crossref funder ID, the ROR IDs, and recently, and I'm going to speak a little bit about this, also we are fostering the use of DOI for funding opportunities and for awards, so we can track all the different nodes of the research life cycle. So the idea of using also DOIs for awards, which is our next step, is we want to provide elements so that DOIs for awards can be registered by the members that want to start using PIDs in their own funding management workflows. This metadata schema can accommodate to the majority of the requirements for awards entities, as currently it is. And our ongoing work, we're working with the addition of award to the resource tab general for the 4.6 version of the schema, and we are in the point of we are requesting comments right now. But the idea of having also DOIs for awards is so we can, as mentioned before, connect the dots and understand how the research life cycle works, how is currently, and to track all the process from the funding opportunity from the governments or the funding organizations to the implementation of the data management plans, the launch of the projects, the publication and the data collection, the publication of the research, and also to track the citations and all the impact that research is having by its own. And all the timeline and all the history, thanks to the implementation of these particular specificities in the metadata. In terms of discoverability and how to connect research, One element that we provide, or one platform that we invite you to explore, is DataCite Commons. This is a metadata aggregator. It's a public site, so if you go to commons.datacite.org, you can find this metadata aggregator that enables discoverability by providing access and also connection to all the works that has a DOI, a DataCite DOI, and also some Crossref DOIs. You can find also people thanks to the ORCID IDs, organizations thanks to the ROR IDs, and of course specific data repositories thanks to the integration of RE3 data for research data repositories. This is interesting because with this kind of services, we also foster the discoverability element, but also to see what the organizations, what the people are doing. And thanks to these connections that I mentioned before, we can identify and find interesting research in the web. And also, in a more graphic sense, the PIDgraph provides all the nodes and connections between the elements. So if you find a work that has a certain citation, we can identify these connections inside inside Commons, but also we can identify this like big PIDgraph where all the data sets that are connected to the publications and the number of connections that it has, the relevance or the connection with the funder IDs, which software has generated these data sets, in which organizations the person that are creating these data sets and the publications are affiliated with, or where are they working. So with these elements, we can understand how the different research life cycle and the landscape of research is doing right now. And going back to Commons, here is an example. If you want to see different universities, for example, the University of Sao Paulo, you can identify all the works that it has with DOIs. Of course, here are more than 4,000 works. It is not all the works or the research outputs that the university has. It has a lot more. But these are the identifier works that has a DOI. It can track also the number of citations for each work, the number of visualizations of each work, and of course the number of downloads of each of these works. Thanks to the implementation of its own organization ID, the ROR ID, you can identify different information, like of course the localization, the type of organization. And thanks to the implementation of DOIs, you can identify, of course, the date where the data sets or the research outputs are published online, and the different types of works. As you can see, it's a very diverse variety of different research outputs that the university has published online. And most of them has CC BY 4.0, a very open license for most of the research outputs. But this is only a part of the whole research that the university has been doing, of course, across their history. So if we foster and we enable if we foster this implementation of best practices to adopt ORCID IDs, to adopt DOIs for our research outputs, for organizations to use ROR IDs, we can track and we can identify more easily what the work of the different organizations and people are. One element that I wanted to share with you is, as mentioned before, the data map, which is a data repository that was one of the projects that we as DataCite supported for the Global Access Fund, and it has all the elements to identify and to track the research that has been done in the Amazon, a lot of data sets in different spaces. that will be tracked, that will be described, and of course that will be discoverable for many, many people around the globe. So we are very, very happy to see this kind of projects, and we're interested to more projects to have this kind of implementations and adoption of best practices, so they can have also the necessary visibility, but also to connect with different other organizations and different other researchers that are interested or that maybe are working in similar things. Also, discoverability fosters this network and these connections between the people and between the research groups. So this is only one of the many other repositories that that are part of this big connection. And we're really, really happy if you're interested to explore more about DataCite Commons and to see what the organization has been doing. And of course, as mentioned before, our public data file is online. I understand that the slides are going to be shared with you in the site of the workshop. But if you're interested to know more in our Zenodo community, you can find the data citation corpus data file to explore these more than 60 million DOIs with all the metadata information on it, and well, to explore and identify how the research has been doing with the DOIs of DataCite, and thanks to the implementation and adoption of other persistent identifiers like the ORCID IDs and the ROR IDs to have a better understanding of the research life cycle. And I think we have only, well, yes, this last part. To understand the impact of this, checking a quick overview of Latin America. In terms of repositories, as the one that I shared previously with you, as you can see, there is a challenge in terms of providing visibility to repositories. So the implementation of persistent identifiers can help to achieve these kind of situations where the repositories have the necessary visibility and, of course, accessibility to the research outputs. And when you have good practices and when you start to establish from your policies and from your, the adoption of better practices within your communities, you can achieve a lot of visibility, like the cases of Brazil and Peru, of course, and other cases like we know and we have identified that there are a lot of repositories, but not all of them are reported or registered in the open spaces. And this makes a little bit more challenging the situation, so the researchers can identify or have access to more platforms where they can discover or publish their data and the research outputs. So this is a very quick overview of the Latin American repository publication. And also, as mentioned before, in terms of implementation of better practices, as you can see, most of the countries in Latin America have implemented open science national policies, but there's still a lot of challenges in terms of how we implement in the technical part these practices and these policies, because I may say that I have a national policy on open science, but if I am not enabling the necessary infrastructure, if I am not enabling the necessary practices like the metadata quality that Giri shared with us in the last presentation, if I am not implementing the necessary elements for discoverability, there is no point on having open science or saying that I have open science practices or I'm implementing open science practices. It requires a lot of efforts from a lot of different entities, as I mentioned before, and with that aligned, we can foster and we can enable more access and better quality research, and also we can also share with the world what we are doing and also connect with more research groups. So for us, it's very, very important to have the possibility to work with organizations, particularly in my side in Latin America. but to also to incentivize and make aware that the importance of having incentives and, of course, policies, but also to work and support infrastructures like the ones that we are going to see today. So we invite you to also follow the FAIR principles to be part of this change by registering DOIs to all your research outputs, to use your ORCID IDs or your researcher IDs like ISNI. So, and include, of course, relational metadata like the one that the Oak Ridge National Laboratory shared with us earlier today. These better practices can help us to share these success stories and also to, well, implement better practices in terms of findability, accessibility, interoperability, and reusability, and also to provide the necessary acknowledgement to all the people and all the organizations that are working and, well, putting its own grain of sand in the research life cycle. And without further, this is our contact. If you're interested to know more, please contact us at info@datasite.org. And we're really, really happy to be here with you. Thank you so much for your time.
Thank you very much, Arturo. I think when you see we saw the presentation of Arturo, we know that we have a lot of lessons to do here in South America, mainly because you have to do a lot related with open science. So now you have a little bit break, 20 minutes of break. We have a coffee break here. Everyone here is invited to go to this coffee break. The people that are online, please just wait in 20 minutes. We are come back in 20 minutes and start again the workshop. Thanks so much.
So, continuing our program, it's my pleasure to introduce Professor Pedro Correa. Professor Pedro is a full professor here at the Department of Computer Engineering and Digital Systems at the Polytechnic School at USP. And he's coordinating several projects. One of them is the data side project in association here with the Institute of Physics and Unicamp as well. And please, Professor.
Thank you. Thank you, Professor Luciana Rizzo. It's a pleasure to be here, to come back. I will talking about the infrastructure that we have worked in the project Data Map. The name of this project that was supported by GAF fund of the data site is Data Map. This Data Map is a computational infrastructure for supporting the data management and analysis of the aerosol data in Amazon. This project is it's a joint collaboration between INPE, USP, Unicamp, and thanks our supporters of this conference here right now, Centro de Ciência dos Dados, Biomaker, AI, and e-Acesso. Não, acho que está aqui do lado. Aqui. Não? Você troca para mim, então. So, next slide, please. Just introduce the team. Luciana Varanda Rizzo. She is professor in atmospheric physics laboratory at Institute of Physics at USP. She has undergrad, in master in physics and PhD too at University of São Paulo, and postdoc in this area in NCAR Center at USA. Alan Calheiros, he is full technologist and professor at the grad program in Applied Computing and National Institute for Research, INPE, or NASA, and degree in methodology from Federal University of Alagoas, master and PhD in meteorology. Alan, and me, that I am work here at the University of São Paulo at the Escola Politécnica. So the team that work in this project is Rosa. All of them, they are grad students related with some research, some related with grad programs here at computer, at physics, at meteorologists. They are involved at INPE, or they are part of them involved from USP. And you are going to hire another one from Unicamp, maybe in the next 2 or 3 months, Davi. You need someone from there. And here we have Rosa Virginia. She is PhD student at the EASH. EASH is another USP campus in information system. André Maia, he is master student at Escola Politécnica. Caio Maia, another student, under the grad student and master program of electrical engineering. Aline Andrade do Nascimento, she is PhD student at INPE. Elvésio Leal Neto, PhD student at INPE. Wellington Dias de Queiroz, he is master student at the USP. And Felipe Valencia Almeida, PhD student at our program in electrical engineering. So, data map is related with 2 huge data sets. One huge data set is related with data that was collected in situ in Amazon. One is related with LBA, large-scale biosphere atmosphere. This is, I was talking about this project. This is the third year or more, started 30 years ago. And another project is free air CO2 enrichment at the whole ecosystem scale, Amazon's phase that started collecting data officially maybe in 2022. We are going to have more information about this project this afternoon. So let's talk a little bit about the LBA. The LBA, the objective is long-term Brazil initiative to generate scientific data to understand the functioning of Amazon better. This project has some permanent site collection in 10, let me show you, 10 towers. Oh, I don't know. Is it working? Okay. No, it's okay. No, before. Okay. We don't have pointer here, but, okay, here. We have 10 sites that collect aerosol data in our Amazon. One important is Atto. Atto is the tallest tower, like bigger than Eiffel Tower in France. And this is just to show you here. This is the Atto. Atto is a collaboration between Brazil and Germany. And the German is a Max Planck coordination that they are responsible for data management in Atto. And some of the towers we have available, the data is available at our LBA infrastructure that you have now is a FTP site. So this is the what we have here in thinking about the science and the collected data in situ. And part of this data is available in NOAA and Aeronet USA. This is two infrastructure that are aggregating this data, collecting aerosol tower. So the challenge for us is aggregated all of this data that are collected in different repositories, but you don't have just one infrastructure to analyze this data. So we created an infrastructure that aggregated all the data sets, and other data set that you don't have published yet here is LBA infrastructure, is FTP. So the data map, the challenge is aggregate all of this data. So this is our challenge here. And another short introduction about the Amazon phase. The objective is comprehend the future of forest in light of climate change, deforestation, degradation, and fires. This project involves researchers for different countries, Brazil, of course, UK, Germany, USA. I think there are more, but I put a list here. And they started to collect data in 2022, maybe before, but this is the one key data that I have here. So this is the kind of infrastructure that we have in this project. Let me check here. Here. This is one plot. We have this ingest carbon, and there is a lot of species. They understand, they have a lot of sensors here that will collect a lot of data here. In this project, we have 6 of these in Amazon, and they have 5 different tasks to understand in thinking a scientific problem, to try to understand it and these different tasks here. So considering the problem here that we have is similar that we ARM have done. How you collect good data, how you processing the data, how you can publish this data. This is the data cycle that we must do in this project. And, and this is our challenge here is developing an infrastructure for data acquisition, data quality, and the data publishing. This is the main challenge. So this is the infrastructure that we started, and we call the Data Map Amazon. And the idea is involved greenhouse gas in Amazon with a large of amount data. We have a large of amount data collecting different in situ data that in Amazon. We have this opportunity of GAF data site project that we submitted last year to make development tools and make the data curation of all data that was collected in Amazon Face, that we have a lot of data collected there, in LBA. This is our target in this GAF data site. And you are going to deploy the data map as an open source. This is our challenge too that we are doing. So the general goals of this data platform is building a data discovery, data visualization of this data that was created in this infrastructure, a platform for data processing, and the idea that you have unified place where you can make data discovery, and if you don't have a data infrastructure for analyze, you can analyze this data set. This is what your idea, your vision in general. So in this project, specifically this project, until January, we don't finish yet, you are going to deliver this data map Amazon that is a platform of computer and software tools to manage and publish data sets collected from a long-term initiatives from LBA, specifically in this project, and the data that is available in Amazon Face. So what you have to do is curation of these legacy data sets that is available but is not published yet. You must do some curation for this data and deploy this data in this infrastructure, and training researchers in using tools and publish data set in Data Map Amazon. Part of this we are going to deliver tomorrow. Tomorrow you have a workshop. This is a very informal workshop, but they are discussing how you publish, how you make data curation with the team, and everyone is invited. This is open. We are prioritizing people that are involved in this project, but of course, everyone is invited. So let's talk about, in general, this data map platform. So data map is a collaboration between ARM. We are working together, learning a lot in the last 10 years with collaboration that you have with ARM, understanding all the problem of data management. So the idea of this platform will focus on visualizing, discovering, cataloging, processing data sets and machine learning models. Enable sharing, searching, rich visualization for, this is the name of bioclimate, aerosol, and some information about the species that you have in this data set. So what you have done? We have different data sources that they collect data. They just collect data. We have legacy data that was collected here. We just have this data lake that was made last 2 years. This is a nice work that we have done in our team have done here. So you have this data available. This data available, you are working here, processing this data, collecting some metadata here. Some of this data we are generating at CDF here. And this data curated, you are make available for publish. And we are make available for create some Jupyter notebook in our data, in your portal. So this is what we are looking for. This is our roadmap. So we are talking about the data set. So data set for us is a collection of files, and for describe the collection of these files, we have a dictionary, standard dictionary that we use, scheme.org, that was created by Google. It's this is a standard that we use for created our description of the data set. So just understand what you are doing, because when you're talking about the repository, data repository, you have a lot of solutions. We have, for example, generalistic, oops, sorry. You have general repository. You have some specific domain science, for example, where you work with ecological data, for example. And you have specialized format, specialized metadata. Just for the idea is that if you have your data should be findable and reusable, they should be in the right repository. Because if you don't put your data in your right repository, people they will not find, or they will respect your data set. So just understand. So let's see what you have about the repository here. For example, one very famous repository is Zenodo. Zenodo was created by CERN. You know, CERN is a very interesting project that was created Zenodo as a infrastructure, but they are generalist. They just you can for example, you can put here presentations, you can put Excel files, you put everything here. When you're talking about domain specific, you have, for example, ecological data, so there is some infrastructure that makes this kind of repositories. And when you talk specialized format and metadata, is like ARM, for example, you have this kind of solution, this kind of repository. So when you see about the repository, you have a lot of solutions. But to be findable, reusable, and complying with the requirements for collecting metadata, you must take care about this when you try to find a right solution for your repository. So we are considering this point here as a repository. The concept of data map was created as a service all the time. We just start data map as a service. So the idea of data map created REST API when you're talking technically, you are talking about data map. So the concept of data map was created services here. You can integrate the service in different cloud infrastructure, like you can use, for example, some services from Amazon Web Services, but you can use Google too. You can integrate some very nice infrastructure for open science, like Open Science Foundation. It's like a portal that you can aggregate different repositories. You can aggregate it, a lot of services in just to have on one portal. You connect it there. You can access a lot of information about your project. This is nice, and so you can aggregate, for example, in this infrastructure in Slack, and you can aggregate data map. This is the idea too. So the idea of data map that you can make your data set available, and you can develop some experiments using different infrastructure, and you can use your infrastructure. You have, for example, in this project, you can make available the data portal in Unicamp, for example, the Amazon Face. But the data is one repository, but the interface is in Unicamp, for example. You can do this. This is what, because this just serves, and the interface of data portal is a different website. So this is the idea. We are releasing now this first version of data map. You can access data map. Now, this is the address. This is the address that we are doing right now. And you can access the alpha version. So this infrastructure, we are using contained Dockers for enable hybrid environment. So if you have containers, you can deliver in on-premise infrastructure that we have. You have on-premise infrastructure like your computers that you have in the lab now, but you can deliver anywhere. So this is the idea that we have Docker. And the idea that we can make available some service in Amazon Web Services, because you are working to Amazon Web Services, because you don't have clusters, nice clusters that, for example, you have in ARM. Our cluster will be this is the idea that we are considering here. So you have credits. So this is what we have. And for indexing the metadata, all of metadata, for you make some data exploring, you are using Postgres, a relational database. We are creating APIs. You are using APIs, but you are making available these APIs, you use the HTTP REST. What is the idea? The idea that we can access all data, all services of this infrastructure remotely. You can create, for example, your Jupyter notebook and access your data. You can create in your notebook, you create your Jupyter notebook and access the data. You can make visualization of the data, everything. This is the idea. So in this infrastructure, you have you are using the standard OpenAPI. OpenAPI is interesting because OpenAPI is everyone is using as a standard for created APIs. You are not creating nothing new, but using standards. This is important. Considering using standards. So you have flexible authentication and authorization. Now you are using OrchID. So you are asking to all researchers has OrchID today. So you are using OrchID for authentication and authorization. For example, if we connect there, you are creating a user for you. You're using our OrchID, and you can, for example, deploy data, but you can manage the data. You have some authorizations for each kind of different users. And data site integration, you are integrated with Fabrica of the data site. Data site has two environments. We have an environment for test and production. We are connected for both, and now we are deploy real DOIs in this infrastructure right now. As I told you, we are using OrchID now, but you can use any others, like, for example, LATS platform for login, yeah, and for authorization. But now you are using OrchID for general because we can access for researchers for everywhere, not just Brazil, in all countries. What you can say more here? You can upload and download your data set. you can have information about your profile as a researcher, for example, you understand what I can do, what kind of authorization you can access, or I can deploy data, but I can make others administration tasks that are specific roles for do this. And yeah, and you can make some digital object identifier, considering, for example, the idea that you worked with versions of the UI, because when you have a data set, you create a UI, but I can manipulate, create a new version of it, okay, processing this data set. So we are considering and we are doing this in this platform. So this is what kind of thing that we are talking about, data set management with DOI. What is the next step? What you are planning for doing this platform? One nice feature that you would like, for example, I have my data set, but I need to reserve a DOI just for publish. When I publish, I will make available this data set. It's like ARM have done this, and you are considering to implement until January this. So one is, others is just, I was talking about data quality assurance. Quality assurance is to manipulate, to manage the data quality information as a metadata, indexing this information for data exploring. This is what you're talking about here. And the idea that we have a Jupyter notebook inside of platform. So, for example, I don't need to download this data. I just can create it. I just can plot this data, the data set. So the idea that we can launch a Jupyter notebook. This Jupyter notebook can run in our platform or can run in Amazon Web Services and in this infrastructure, but we don't need to know. And we can, for example, make some very simple tasks in this platform, but using Jupyter Notebook, because you are deploying not only the data set, but the Jupyter Notebook to make visualization of this data set too. This is the idea. And of course, you want to do a very nice visualization. I don't know how much we can have some good results until January. Our students is working this. So, it's a short presentation, but some lessons. What you have learned about the data map, about the repository. So I will put some lessons here. One important thing is be transparent with your methods, platform, and infrastructure, because you can make, everyone should know what you are doing if your data set. So this is one important thing. Another, clear data policy for data management. Everyone knows about the data policy, that you are doing this with this platform. Be prepared for operations and evolutions of technology, because we are not thinking about 5 or 10 years, maybe 30 years. In 20 years, we changed the technology for storage, for example. So we are considering this, because this data that you are cataloging there will be for next generation, not for just will be in 20, 30 years. People are going to use this data set. Consider to use NetCDF. NetCDF is a standard for data collecting for instruments. It's very nice. It was developed by ARM. Part of this, I believe, was developed by ARM, you know. And but the metadata that you collect, the idea of NetCDF is for data exchange. And you have standards metadata for data quality, for instrument, for all metadata related with the data set that you collected. So Consider to use NetCDF. You are using NetCDF as a standard. You are starting with NetCDF. But we focus if okay, I will collect metadata, you stay this metadata aggregated in NetCDF, but must be quality. Must be with quality. Continuous understand the nature of our business model and value chain. It's interesting because this is not free coffee. We must pay for this. I was talking with Gear yesterday. When you're talking about data management, should be interesting in your project. Consider at least 10% of our budget, for data management. So this is a legacy that our project. So in general, if you need a number, consider that 10%. 10% is good start. Stay engaged in collaboration, international collaboration, because you don't need to start to do well all the time. Because, for example, ARM is working 30 years. You aggregate some experience of ARM, aggregate some software, some solutions, some tools. Tomorrow I'm going to show you what you have done using some of that data quality tools from ARM to collect metadata for make data curation. Tomorrow you're talking about this. So don't work together. Don't work alone. Work together. Work with mainly with international. So make international collaboration. This is very important. In your case, it's important to consider to focus. Our problem right now is data quality. Data quality is I think this is our problem is data quality, because you are collecting data, but you are not doing provenance, you are not doing information about the data that you are quality. If you don't have good data quality, you don't have good data set to publish. So this is the idea for us. In this moment, we must consider focus on data quality. When you're talking about data quality, you are talking about people. That people is training, because you have tools, but you must have people that knows how to use these tools. So we must consider qualification of people. Mainly we focus in the data quality. This is one important thing. This is what we prepare to talking about the data map Amazon. And thank you very much for you, everyone.
Thank you, Professor Pedro, for the very nice presentation. So following up, we will start a roundtable here. So I would like to invite for this table Professor Pedro, that is sitting here, so please. And also would like to invite two of our previous presenters, Dr. Giri Prakash from Cornell and Dr. Arturo Garduño Magaña from that site, please. So we can get questions from the audience, but I would like to start making a broad question for, and then you can make comments on that. Well, I'm talking from the point of view of not a data scientist, but a scientist that goes to the field and collects the data. and have a lot of trouble with the data management. So I'm very glad to do this collaboration with you all, especially Professor Pedro, with whom I work more closely. But generally speaking, where do scientific groups that still didn't follow the data management practices, where to start? Where would you recommend people to start having a more consistent data management process if the group doesn't have a group structure yet?
Okay. Well, where to start from a scientist perspective, right? So you start when you plan for your data collection. So when you are planning for your instrumentation or modeling, that's when you start planning for the data management. What are the first initial steps? Is to describe your plan. What are you doing? Be it a field notebook or any planning that you do. Okay, this is the experiment I'm going to do. So describe in a way that it can be reused when you have the data. Now you can actually apply. Okay, this is the methodology I used, and these are the output variables that I got, and here are the results I got. And then when you prepare the data, right, like initial data, it has to go through a few things, like be it CSV or ASCII format, it doesn't matter. But then when the data management team takes that, they can ingest into NetCDF or whatever. So as early as possible to start. Just talk, having a conversation with the data management expert in here, Professor Pedro. Hey, this is what I'm trying to do, and what are the basic information you need? Do you have any tools that I can use to describe? So we have tool, data planning and registering tool. It will ask you like what's the abstract, what's the very similar like basic metadata that could be not only used to describe but also get the DOI at the early stage itself. So you don't have to wait for your data to be ready to get the DOI. You can say, I'm going to generate this data, and for that, I want to have a DOI reserved, and DataCite will be able to give you a preliminary DOI, and you can actually put it in your data files too. So earlier, the better.
Definitely, totally agree with Yuri. And this is something that I was discussing with Michael earlier today before the session. And as soon as you start with your plan or your planning in the project, you're going to have more clarity on what you want to do, what you expect to achieve. And of course, if you also are aware of the benefits and the incentives of standardize all the process, all the implementation, and all the benefits that you have by doing so in the near and the long and in the future, you are going to be able to implement it in a better way. So as earlier as possible, and being aware of those benefits, it's also very, very important.
Just give some advices. We are looking for this problem when you have two heads, one head of data management, one head of end user, a scientist. As a scientist, we need to make a new generation of scientists, mainly here in South America, because we have a lot of infrastructure, and I think most of us, we are not prepared for teach, for make some devices, and for our students make some, how they can make using this infrastructure very well. So I think we have for researchers, you must consider that you have an infrastructure in the world. You have DataCite, you have ORCID working, you have DUI, you have repositories. I can choose each repository is better for me, my science domain. I need to make good choices because, okay, it's easy to, oh, I can publish in Zenodo, but no one will find you in Zenodo because if you are specific, okay, I just need to publish my Excel file, okay, you can use Zenodo. I just need to make my report, for example. I prepare a report for FAPESP, for example, I can publish there. But I collect data in Amazon, I publish in Zenodo. People, data in your data set is Zenodo. I can publish in ARM, I can publish in... So you can make right decisions. So as new researchers, you have to do using this infrastructure and make right decisions in this infrastructure. Using another head, consider data, the people that are responsible for create this new infrastructure here in South America. We must think about this. You have a gap here, a gap about the data published. We didn't see any repository with Core Trust Seal. When you're looking for Core Trust Seal is a stamp of which repository I trust to put to make my data available, my data set available. You don't have nothing there. You have in Europe, you have in North America, but you don't have in South America. You must train people. You must train people to use this infrastructure, and you must do research in this area. I was talking with Jean Ometo about this. We have a gap in data management, mainly here in Brazil. But we don't have a researcher. We must do research to give directions, and give direction, you must implement this, make available for to cover this gap that you have in data management. I like the presentation that you had this morning, that we show the situation about the data published here. So you have some nice repositories, for example, here at USP, but you don't have DUI yet published. You have 400 data sets available in all institutions. But it is like Zenodo, general repositories, not a specific repository. But, you have a gap. You must, considering the data management situation, on the other hand, you must take care about this. Thank you.
One more quick point. So it's more like a question for you. So in the US, and just taking as an ARM as an example, if a PI proposes a field campaign, and when they submit their proposal to use the ARM instruments or ARM facility, one question is data management. What data are you planning to generate? And so is there something like that here? You have to identify the repository, and then you have to give like the data, collect the data that you are collecting within 6 months to the repository. So is there one?
Yes. Here in Brazil, just Gary, because here all the audience is researchers. We submit projects for our science foundation here in Brazil. We must prepare a data management plan. The question is, the researchers, they are not prepared to do this. They don't know which better choice to do with decisions. If you do anything, the FAPESP, CNPq, you accepted this data management plan, because you're make some obligation, just this. Now, but we must train our researchers, our early researchers in this, because we must use well these tools that we have available now. Okay. Thank you.
Thank you. Thank you. Jean Ometo from INPE here. So this, I think one of the challenges that we face here in Brazil, and interesting aspect from ARM is from the US Energy Department, if I'm not wrong, and is how does the public resource, thinking on long-term curation of the data and conservation of the data, and how the, let's say, a public universe should play a role on this perspective, and how much of that the private universe would that be relevant? So it might be something very related to our reality here in Brazil. So what happened a lot is that the funding agents require for the researchers to have a data management plan. But that normally it's a devolution for the drawer we had in the past, that we had the data in the drawer. It basically becomes into the institutional data infrastructure. And that has all the issues, in particular related to access and to long-term maintenance of this data set. So that's one point. And another point that I think follow-ups a little bit on that is how to deal with sensitivity of data in terms of health and social data, agricultural production and storage and things like that, when you're kind of dialoguing among those two universes. So what are your perceptions and feelings on that? Thank you.
Okay. That's a great two questions. Yeah, the first one, when you say public, my mind says any user, right? So any user of our data from, like I showed you a slide, 34 countries, people from 34 countries, they used our data. So giving a high level confidence is one. And then the actual question is like, okay, so the users or the public gets the data, and our public majority significantly are scientific users, right? So now, so people who are studying climate, they use our data. So they have working groups. So these scientists from throughout the world, they have working groups, they have workshops and other things. So they get to provide feedback about what we are measuring. Is this helping their need? Or they say, I need these additional sensors, or I need this additional data. Can you figure it out? Can you provide us? So there is a feedback mechanism to the ARM facility where the public, in your case, or the users, or scientific users, they get to provide on a very regular basis.
Thanks. So, sorry to just follow up. It's just because I was a little bit thinking on terms of finance. So the public fund compared to private fund in terms of infrastructure and all that. And thanks a lot for, and I think that clarify a lot in terms of access on the data set, but also in terms of, long-term maintenance of these compares of those.
More like a sustainability of
something like that. Thank you.
Yeah. So the ARM specifically is funded by U.S. Department of Energy. So it's a federal government funded facility. And the government actually have the confidence, okay, this facility has been operational 30 years, we will continue to operate. So the public actually, in this case, the scientists, they actually influence, they provide recommendations to the people within the Department of Energy. Hey, this is such an important facility, and we need this to continue. So that's the sustainability model. So we don't get private funding for the ARM. It's all from the federal government, and it's heavily influenced by the scientific community. So that's one part. Yeah.
I'm sorry,
Okay.
just
Yeah.
Sorry,
Go
just
ahead.
adding a point in terms of
Yeah.
infrastructure sustainability. And we know that this is something that replicates all over the world, but particularly in Latin America, it's an interesting challenge because as you know, sometimes as government changes, the agenda changes, and sustainability gets complicated. It's challenging, but as soon as we understand and implement certain open practices like the repository that is going to publish their source code open, we can foster and empower the community to understand and gain a better understanding and skills in terms to adopt and maintain the same software and of course the same infrastructures. But we depend a lot on the funding, as a professor said, for the infrastructures, and it's a really interesting challenge. But I think that as we are aware of that and as we implement certain points of safety points where we are opening our developments to the community, we are going to have a better chances to push the sustainability for the longer term.
Yeah, yeah. And the second question is, how do you deal with the sensitive data, right? So at ARM, we all the data that we collect, it's really open data. So we get the raw data. We try not to give the raw data out because we need to assess the quality and make sure, address the quality before we give it to the users. But I have involved in the past with other projects that contains this sensitive data. And so there were various things like the authentication of, okay, who gets accessibility, who gets what. So those things are built within the system, just like any other system that you use. So if there is a PI team, a team of people, they can access to this sensitive socioeconomical data. So they are managed in this authentication. And whatever system that you are all building should have that capability already, right? The authentication, yeah.
This is a requirement, I think, in the future for data that we are collecting in situ in Amazon, because you have some traditional people, they are deliver their data, and we must consider different strategy for recognizing, because when you're recognizing for publish for us, it's like, okay, citation, data citation, but for traditional people that give information about the species occurrence, for example, I don't know, or give some information about the data that they collected in the acknowledgement that they know about this data that they collected, we must consider a different way. This is a challenge for everyone, and I think there are some solutions, and there are some researchers related with this, but people are considering this for the future, yeah.
Hi, I'm Marcio Teixeira from Unicamp. Thank you for your presentations, all with you. Actually, I have two questions here. Let's say I'm starting a new project. I'm collecting data, so I'm starting from zero. So the first question, and I have more or less an idea of the answer, but I want to hear from you anyway. What would be the right format to store this data and convert? And imagine that I'll collect data in text form. I may have images, I may have surveillance from drones, I may have meteorological stations, those things. So first, what would be the format of choice of the data? And second, is there, or can you recommend any tool where I can convert to this format of choice to make it easier to, ingest this data in the database, for example, Professor Pedro's database or ARM, whatever? So that's my question.
So, well, I wish there is a magic button, right, in the keyboard. Click it, and everything is taken care for you. Maybe in the future. Until then, yes. So the data that you are generating, I mean, like we talked about it, but John has said there are data, socio-economical data and other things. So you can't really force everybody to use one format. But what you can do is, like, whatever you are using, CSV, use a template, and NetCDF, use a climate forecasting standard. So as long as you use a standard within the format that you are capturing, there are crosswalks, data crosswalks. There are like metadata crosswalks and ontologies. So like there are tools that will convert your CSV into a different format. But the key point is you have to use a standard within the format that you are choosing. And when you give the CSV data to Pedro, for example, in his data center, he will have ingest script that will convert your CSV into the NetCDF or whatever format that you are going to support, and then it will apply all the right metadata and so on. So please talk to Michael between now and tomorrow or until, yeah, so
Absolutely.
he has a wealth of knowledge and he is the one dealing with all this data conversion. And I forgot your second question.
I was just asking about the conversion of these tools.
Okay. So I think
because I'll have many formats. So,
Yeah.
so the idea is, if I understood correctly, I just need to be consistent. If I
Yes.
choose a spreadsheet or whatever,
Yes.
if I
Yes.
put a NetCDF,
Yeah.
it needs just to
Yeah.
inform this to
Yeah.
ingest the data.
Yeah. Please do not put your description and then like the observations inside the spreadsheet and also the data.
Got it.
So
Yeah.
yeah, the technical report should be outside of your spreadsheet.
Like Aeronet, that you have the description in the first rows.
Yeah, that's
Okay.
right. That's right.
Thank you.
Yes, and always remember also to connect all these elements and versions of the data and the results. That's the benefits of using identifiers, because with that you and all the other researchers can track all the connected elements.
Like GDPR, you know, from Europe or here in Brazil, we have the LGPD. There is a general law of data protection, something like that. Do you think it's possible to create a regulation close to what Jean was talking about, to have the control of this data quality, the data transparency, legibility, and so? Would it be good? Would it be a good strategy? I don't know if I made my point clear, but eligibility. Yeah.
Oh,
of
yeah.
course, I'm not just talking about
Yeah.
personal data. Right?
Okay.
It could be overall, like climate or like
Yeah.
he was saying, aerospatial and blah blah blah. But
So
anyway.
yeah, well, it has to be case by case, right? So you, as a program lead, you will decide what data that can be disseminated broadly to everybody, and what needs to be preserved, restricted, and all. So the minimum set is what are defined by the Core-Trust SAIL, for example. They say, like, if you want to follow our data management practices, fair practices, these are the minimal set of things that you need to do when you try to give the data broader. But like you don't have to make all the data available to everybody in order to meet those requirements. So you, as a program head, you can decide what data would be helpful to broader scientific community. Yeah. You have any?
Great. Thanks. Anyone else? Okay. Anything in the chat? Okay. Sure.
Okay, so my question is about automation, because we all kind of know that automation is important, especially because, Pedro, the last bullet point on your lessons learned slide said people don't scale, systems do. We all know that inherently, but as a new project, many scientists have a choice to make. right? Automation is difficult and expensive and takes up a lot of time. And so we all know that that's something that we all want to strive to, but you can't always do that. And so my question would be, and I know ARM, we've struggled with this as well, and that's kind of the stage that we're in right now, is automate everything, because we've grown to a place where we can't afford to not anymore. But as a starting organization, it sometimes is easier just to walk over and get the data, put it on a flash drive, put it in a drawer somewhere, right? Like that's the reality of the situation. So what would you say are the signs that you need to start automating before you get drowned in work? Because I think that that's important for people to realize. You may not be able to automate in the beginning, but how do you know when to do it before you start to drown?
From my experience, like we had to go through this painful, right? So very simple answer. If you do some steps, and if you are not adding any value, okay, you, an expert, looking at the transform or look, okay, I need to take this data and put this in here. If I'm just clicking the button or copy paste it, if I'm not doing any value added, if I'm not like, oh, so this is looking like this, I have to do this, that's a basic one that needs to be automated. So if the human is not giving any value in that specific step, automate it. And then the second step is, if the human is doing 5 different actions and that is consuming 50% of their time, think about automating too, right? So.
Yes, and also, I'm not an expert in automation, but the very little insights that I have is that it is really important, and we have said this before, to standardize. If we standardize and we implement the correct planning from the beginning, it's going to be easier to provide the necessary information, because by the end, the automation is this correlation of algorithms that gather this information and then helps you to easily process X process. So if we understand that, and from the beginning we have this possibility to add the necessary information to the process and to the data and the system, it's going to be really, I think, more easier to define where and how to automate certain processes.
That's for the new program, right? Like for existing program, you have to continue to look at an opportunity to automate. And back in 2018, we did a major streamlining on automation, which saved us quite a few person years, basically, by automating. So we went from 100% non-automated process. We actually did like almost 80% of those are automated. And initially, people in the projects like, oh, what am I going to do? But soon they realize they can do much more interesting stuff, right? Yeah. So
a better use of their time.
Yeah, better use of their time, better, more interesting use of their time than just like a mundane, oh, I got to come, I have to do this every day. So now it's all automated. I just need to look at it. Is it going okay? All right, let me do some fun projects, you know. So that's another thing. And going back to Pedro, I can't stress enough, 10% is the minimal amount for managing data. When a new project is funded, or even before funded, when the proposal goes in, you have to allocate 10% data management, and that will give you enough resources to get started with the right way. And within 3 months,
it's a little bit complicated. So in terms of data governance, to understand who collected the data, if it has sensitivity in the data in terms of species in danger of extinction, or certain places that has to be protected. It is important to understand and have a very good awareness in that aspect, so we can provide the necessary elements from the beginning to provide in the models and the standards the necessary treatment for the posterior data curation. So I think that's also a very important challenge to have in mind from the beginning.
Well, so yeah, I think like we are going back into this like from the outset in the morning presentation. If I am a scientist new to data management, if I am listening to that, it is a bit overwhelming for me, right? So I guess I want the scientists to know it is not that difficult. It's just like connecting with the right experts, just like how you make use of a technician to fix some sensors, or an engineer to fix some networking. So it's the same thing. Data, there are things that can be done very quickly, but it will be still conforming to standards. So understanding or making the PIs understand it is not as bad as you think, and it's not as complex as you think. Is a grand challenge that we have to keep educating them.
I think our main challenge here right now, how you can use your university model to training students and deploy infrastructure. This is one big challenge for us, because we are not the, as I say, like an institution that will deploy software products. Our problem is how you can do researchers. We can do research, we can training students. So we are trying to accommodate this to solve our problem here that our community, scientific community that you have. So what you are trying to do is how you transform this, what you are doing here, as a research. It's important because if you have a research, okay, you have directions, you have some, what directions I can do this, and we can deliver for organizations to deploy this as sustainability, but now we are trying to find a good model for aggregating grad students with deploy new solutions and to achieve the society problems. Thank you.
Well, thank you. I think we are running out of time right now, but I would like to thank you all for your comments, and it was very important to have this conversation here.
Yeah.
Thank you very much.
Yes, thank you.
Thank you.
Let me take a look at the agenda here, but if I remember well, it's 1:30. We have lunchtime now, and 1:30 we will come back here for the talks in the afternoon.
Yeah, just general information about the logistics here. We have a restaurant not so far from here. It's a fair restaurant, and you have a buffet there, so everyone could be there. It's easy, and we can come back at 1:30. It's perfect. Thank you.
let's start our second round. The next speaker is Professor Davila Pola. He comes from the University of Campinas. The talk is about the Amazon Face, a nice project. Please.
I don't know what I should stand here. Você vai ficar aí mesmo? Tá. Okay. Okay, good afternoon. Thank you for the organizers, Pedro especially, for the invitation. It's an honor to be here, and I think it's something that small and big projects are getting more and more concerned about, which is data management. Is something I personally take very seriously, even though I have to confess, in the beginning of my talk, we are not doing the home lesson here in this regard. And there's a lot to improve, specifically for Amazon Face. That's why we are here and hope to count. We are already been counting with Pedro's help, Caio as well here. So, given that, I will focus my talk more on explaining the Amazon Face project. Of course, we're going to touch, by the end of the talk, I will touch the current status of our data, which I tell in advance is not very good yet, but okay, let's go for the science. So Amazon Face is a research program, is officially a research program of Brazil's Ministry of Science since 2014. And after passing, is it still working? Yeah. After benefiting from fundings, smaller fundings from several agencies, the program is now funded by MCTI itself, Brazil's Ministry of Science, and half of it is also paid by the UK government, okay? In terms of the execution, it is executed by INPA, the National Institute for Amazon Research, based in Manaus, and coordinated by Unicamp, my university, University of Campinas, with the participation of the Met Office, as well, the Meteorological Service of the UK. All right. You probably heard about the Amazon forest dieback hypothesis, which is a more than 20 years old hypothesis now. It came from the modeling realm. I will explain you briefly. But later on, this hypothesis was translated to savannization of the Amazon, and now, more recently, it's called like a tipping point, the Amazon tipping point. Basically, what it says is that if we have extreme climatic change in the region, extreme rise in temperature, an extreme reduction of rainfall in the region, which is not so difficult to think these days, given the scenario we are seeing there, we would lose the conditions of having a forest like we know today, and we would have, like the map on the left is showing, we would have the climatic envelope typical of a savanna or a dry forest. But on the other hand, the other scenario, if we consider something biologists, ecologists, plant physiologists know as the CO2 fertilization effect, which I will explain to you in a minute. But if we have that effect, the forest basically remains the same. So the CO2 fertilization effect counteracts the bad effects of rising temperature and lower rainfall. CO2 fertilization is, if you remember from high school, that CO2 is a basic input to photosynthesis, right? If you put CO2 plus water and the sunlight, bingo, we have the most wonderful biochemical process in the whole universe. We didn't find anywhere in the universe this process, which is photosynthesis. Then the plant produces a sugar and oxygen. So when you increase CO2, theoretically, and only theoretically, the plants will increase photosynthesis and will increase their biomass besides other processes in the plant. But the problem here in this scenario, and the problem especially given especially concerning this process that seems key to the future of the Amazon in light of climate change, is that we don't know if it exists in reality in the Amazon, how strong it is, how long it would last there. And as a result, this uncertainty has been lasting for several decades, at least 2 decades, right? And as a result, the hypothesis, the dieback hypothesis, now called tipping point, and more recently it's being called also as critical transitions of the whole Amazon. It's still on the cover of main scientific magazines being discussed, even though this key uncertainty hasn't been solved yet. Okay, and I don't want to complicate the story here, but this is important. This graph here is showing the y-axis here is showing the change in the biomass of the forest in tons of carbon per hectare per year. And the black line is the average of several models used by the IPCC, the Intergovernmental Panel on Climate Change. And it's basically showing that the forest will behave as a carbon sink, will be absorbing carbon from the atmosphere basically forever, for the next decades. But observations, the yellow line here, it's showing us that this carbon sink has been reduced. It's getting reduced with time. And if you do a statistical projection of this trend, it shows us the forest should become a source of carbon to the atmosphere sometime in the next decade. So this disagreement between the observation-based trend and the models used by IPCC is basically because of the way the models simulate or consider the CO2 fertilization effect. They basically consider that CO2 fertilization effect exists, it's very strong, and it lasts forever. And that might not be the case. And the only way today is the best way, and the only way of verifying that is via what we call a FACE experiment, using the FACE technology. FACE stands for Free Air CO2 Enrichment. It's a more or less long existing technology. It was developed at Oak Ridge National Lab, but more, I think, by a broader lab, which is Brookhaven National Lab in New York. There has been 2 FACE experiments in the US, in forests, in temperate forests. Both of them are over now. There is one in in another ecosystem in Minnesota, in the US, going on, but it's not a forest exactly. There were phase experiments in Europe, etc., but never in a tropical ecosystem, never in a tropical forest. And as I said in the previous slides, there is a special importance in doing this kind of experiment in the tropics, given the amount of carbon this forest can potentially absorb from the atmosphere. So our question in Amazon Face is how will rising atmospheric CO2 affect the ecology of the Amazon forest, the biodiversity harbors, and the ecosystem services it provides? For those of you who don't know, let me just see what comes next here. Okay, it's a video. But I can go through the video later. It's a technology where we use this system of towers disposed in a circular fashion. And these towers, this circle, it has around 30-meter diameter. And the towers go as high as 35 meters, such as to surpass the canopy of the trees. And each of these towers, the photo here is not showing yet, but we're going to have tubes, hollow tubes here on each side of these cross arms here on the top of the towers. And these tubes go from the top of the towers down to the ground. And you have holes in these tubes facing the interior of the circle. So that's where CO2-enriched air is blown inside this circle, okay? And of course, these tubes, they are connected to a tank of pure CO2 that stay a bit far away from the circle here. It's not shown in the photograph. And of course, between this tank of pure CO2 and the emitting tubes here, there is a whole system of valves, sensors to control the exact amount of CO2 we want to mix with the air. And the exact amount we want to mix here, our target is 50% above the average CO2 concentration we have in the atmosphere now. And given this scenario here, the importance of this experiment for understanding this scenario here, it becomes obvious that this is not only a problem of carbon, it's also a problem of water, because when you increase CO2, this changes the way the trees transpire to the atmosphere. So the input of humidity to the atmosphere changes. So it's a matter of, it's a water issue as well. It's a problem of biodiversity, because this is the first time a phase experiment happens in a diverse ecosystem like the Amazon here, because the previous experiments in temperate forests, they had like one or a maximum of 2 species, 2-3 species inside the plots. And here, considering the 6 plots we're going to have in total, we have more than 400 different species. So for some, it's a nightmare in terms of interpreting the results, but I prefer to consider it's an opportunity for us for the first time to understand how this biodiversity modulates the response of the ecosystem to such an important factor such as CO2. And it's, of course, a social-environmental, socio-economic problem as well, because we shouldn't forget we have something near to 30 million people living in this region, and they directly or indirectly depend on these forests. And this CO2 fertilization effect will be decisive to the future of the forest in light of climate change. So, pode só apertar o play aí para rodar o videozinho? This is just a small video when we had only 2 plots constructed, just to show you the dimension of the thing. And I shouldn't forget to tell you about the cranes. These construction cranes, they helped in the construction of the towers, but they remain there. They are fixed cranes, and they, per se, they are a novelty there in the Amazon. They are the first and only cranes for studying the canopy of the Amazon forest. It gives, so it remains there. The first reason is to help in the construction, but also to provide access of the researchers to the top of the leaves, the top of the trees there. Up to now, it was, in the Americas, it was exclusivity of the Smithsonian Tropical Research Institute in Panama. They had a canopy crane there, but not anymore. Now we have our own here. We can study the Amazon, and of course, it can be used to study the forest outside the plots. You just turn the arm of the crane, and you can study a bigger area there. Here's just showing the location of the experiment. For those of you that come from abroad, so in green, the Amazon here. Manaus is quite in the center of the Amazon. Then we have the detail here, the urban area of Manaus. You go 50 kilometers in a very good paved highway, then turn west in a mud road, which has been improved by the project, because we'll need mid-sized trucks delivering CO2 to the experiment twice or 3 times per week. So the road must be in good shape. And it's also showing here in the inlet the configuration of the plots. As I said, we'll have 6 plots. 3 of them will be treatment, dealing with higher CO2. The other 3 will be control plots, blowing only ambient air inside the circle of forests there. And as you can imagine, or maybe you can't, but so I'll tell you, we have to measure everything we can inside these plots, because the effect of increased CO2 can manifest itself in any part of the forest. For example, it's virtually certain that photosynthesis will increase when you increase CO2 in the atmosphere. The problem is what happens after that. I mean, photosynthesis is the entrance of carbon in the ecosystem. Okay, where does that carbon go after that? That's the big question in terms of carbon for Amazon face. What the world would like to see is this carbon being stored in the tree trunks, because it's a very stable compartment of the trees. But in the end, what may happen is that this carbon will be respired back to the atmosphere right away after it enters the tree. For example, one hypothesis is the lack of nutrients in the soils of the Amazon, especially phosphorus. And you need phosphorus to build cell membranes, DNA, and energetic molecule, ATP, you need phosphorus for that. So if you don't have phosphorus, you can put as much carbon you want, the tree will not grow. And the tree may allocate that simple sugar it produces in photosynthesis to the roots in an attempt to acquire this nutrient from the soil. It releases the sugar in the soil to attract microorganisms, fungi, to give the nutrient to the tree. But they might not do so, and the tree will be losing the carbon there. So it will enter the system via photosynthesis, it will be respired back right away. So that, just to give you an example, that we need to measure everything we can. Photosynthesis at the top of the crowns, down to root productivity below ground. We have some nice cameras. By the way, it's showing a photo here. This fine root here, this is a fine root where all the action may end up. It's like 1 millimeter thin. And you can photograph the same spots. You see the fine roots growing, dying, ramificating. It's pretty interesting. Okay, what else should I tell you here? We need baseline data. It's like if you had a patient going through a surgery in a hospital and you monitor the vital signs of the patient before you do any intervention of it. It's the same thing here. We've been monitoring this forest for many variables, not all the variables we wanted, I should say, but for many variables, for many processes, we've been monitoring since 2015. So it's nearly 10 years of data for some variables. Because it's important for us to know the behavior of the forest before we put any extra CO2 there and after. So we can compare before and after. And not only between control and ambient plot. It increases our statistical power, our power of analysis here, doing this comparison also before and after, and not only treatment and control there in the. And given the integrated nature of the way we did these baseline measurements, we found new stuff as well regarding the functioning of this forest. So the baseline itself shouldn't produce any big novelty, but we found some new stuff. For example, the synchrony between the production of fine roots below ground and leaves on the top of the canopy. So there's a number of articles from this baseline phase of the experiment. I couldn't explain you all of them, so I just put the QR codes of some of them here. There's even this open top chambers here. We've been playing around with it while we were waiting for the funding for the big phase experiment, but I will not enter in that detail. The point here is the status. Now, we finished the heavy construction. We are finishing the heavy construction now in the next weeks. When I say the heavy infrastructure means the towers themselves and the construction cranes. And now what will be left is the light infrastructure, which is tubing, sensors, valves, and all this small stuff that is more detailed, you know, and takes time to construct. So the idea is that in May next year, we'll do the first tests with one pair of plots, so 2 plots, one control, one treatment. And this will be both a technical test and a scientific test as well. We want to just show the concept of the system, the CO2 entering. I don't need to enter this detail, but the isotopic signature of the CO2 we're going to use is different from the one we have in the air. So when we start the experiment, we have a golden opportunity to see the CO2 entering the trees and getting out somewhere, either in the soil respiration or in the trunk. And we want to show both the community, the scientific community, and our funders, of course, that the system is working. So this is intended to happen in May. And we could, in principle, turn the whole experiment on with the 6 plots, the 3 pairs of plots, sometime by August or September. So less than 1 year from now, but it seems our scientific committee doesn't want that because for specific measurements we didn't do during the baseline phase, we want to have at least 1 year. We want to do them now. For example, sap flow measurements, the flow of water from the roots to the leaves. This is crucial for transpiration measurements, estimates, for transpiration estimates. And we want to have at least 1 year of measurement. So we can postpone the beginning of the whole experiment in like 4 months, such that we have 1 year of baseline data for those variables as well. And our funders are not pushing us to start just because they want. No, they said you start when you think is scientifically more reasonable to do that. So it's not like early, well, in early 25, as I said, we would be ready, but we'll not do so. So the most probable, was a more recent decision by the committee. We're going to start by late 25, the whole experiment. Okay, in terms of data, now comes the problem. I have to be frank to you. We are in a messy situation in this regard because there has been a lot of data collected, but our scientists were not trained to do this in an organized fashion. So which data was in a different place and with a different format, with different metadata, and we are trying to organize. That's why I think we need workshops like this, right? So this provides a very good study case that we need to work on. Something we could, it was a very small step to start fixing this. We produce, this is our metadata here. This is everything that is measured. The time it was measured, if Kyle could just scroll down a little bit, just to provide an example here. So we have big categories there, the research area, the component, the big process that is being measured, and then the different parameters. And then there is the time, if you go to the right side of the table. There you see the start and the end. So it's all there. It's not, I'm sure this is not the proper way of doing this. I mean, you don't put all this information in an Excel sheet. I know that. But believe me, this is way better than it was some time ago. At least now we know everything. We have where it is stored. We are now in the process of at least passing everything to a single data lake. It can be disorganized, but at least it will be in the same place. And thereafter, we need to start organizing this, filling the gaps, and all the stuff that needs to be done. So the project is ambitious. The question is ambitious. The amount of data that will be produced is big. But we need your help to organize this because I don't think we have in our team of scientists anybody that understands what needs to be done in terms of organization and the standards you've been telling us here during the morning. Se pudesse passar para o outro slide, voltar, por favor. And then I will conclude here, just reminding the ultimate goal of all this blah, blah, blah I've been telling you here in the last minutes. We want to come back to the hypothesis there. We were dealing the large-scale perspective that comes from modeling. Of course, we can't, the experiment alone can't answer us, can't resolve the story of the Amazon dieback or tipping point, however we want to call it. So that's to remind us, we want to upscale from plant organs, the things happening at the leaf scale, the very fine roots there in the soil, up to the continental scale here. If we remember, this is just an animation of a real meteorological event that happened several times through the years here in South America. When you have the transport of humidity from the Amazon to southern Brazil and the Plata River Basin. That encompasses South Brazil, Uruguay, Paraguay, North Argentina. And you imagine, for example, that thing I mentioned, when plants transpire less, when you increase CO2, this might have a relevance at the continental scale because the Amazon is a big area. And the amount of water that will be reduced, the water that goes that flows to the atmosphere will have an impact also for other areas of the continent. These are the partner research institutions. USP is here. Besides Pedro, there are colleagues from Ribeirão Preto, the other USP campus in the interior of the state here, and other institutions from abroad Brazil as well. Thank you very much. I'll be happy to take questions when we have the panel. Thanks for your attention.
Any questions? Okay, all right.
Tem alguma pergunta aí, não? Sim. Ah, tá, beleza. I would like to invite our next speaker, Dr. Paulo Tacho. You talked about the challenges in open science, in climate change in Amazon.
Okay. Did you got it? Aí, essa taxa aí, põe aí. Manda bala. Entendeu? Está trazendo, a apresentação é grande. Está aqui. Porra. Peraí, tá vindo. Isso, tô. Okay. In much of the sense, we will continue the discussion on Amazonia that we started in the previous talk, but I will focus also on other experience other than Amazon facing and the challenges that we have in terms of data management techniques. So basically, I will expand the issue of observational data as well as data from modeling and how to integrate this into a broader perspective. And I will continue in the issue that David just started with CO2 biosphere-atmosphere exchange in Amazonia. So basically, in several experiments we are running in Amazonia, like LBA experiment, Diato experiment, and in the future Amazon Face, we have the challenge to basically to integrate in situ measurements, mobile observation platform that includes drones, aircraft, big ships over the river, with remote sensing observations that are absolutely essential today in Amazonia. So the challenge is actually how to join the species, let's say, in an intelligent and effective way for us to do new science with this data that will be impossible to do with individual pieces. That is the challenge that I think the physics-based approach together with the data, advanced data management techniques can help a lot. So basically, one of the examples that I will provide is the data that we are having from the Atoll Tower. It's a beautiful observatory, 325 meters in the middle of Amazonia in a completely undisturbed area, as you can see here. And we are running this tower for already almost 9 years with a lot of data, including greenhouse gases, aerosols, radiation, meteorology, and so on. The tower, for instance, have 16 different levels where you measure CO2 fluxes and turbulence along the tower at 10 hertz. You can imagine the amount of data that we collected, 10 hertz for 9 years, continuous measurements in 16 levels. It's impossible for the mind of anybody look at this data without really advanced data management tools. And then Davi explored the issue of the carbon cycle, but in Amazonia, it's impossible to dissociate the carbon cycling from all the other environmental variables, in particular precipitation as well as radiation. For instance, in this plot, this shows these are drier forest and this is wetter forest. Basically, the amount of above ground biomass depends very, very much on the amount of precipitation. For Amazonia tropical forest, Congo tropical forest, as well as Southeast Asia tropical forest. Different regions have different sensitivities for that, you know, and in a climate that is changing very fast, this is again a new challenge to try to predict the future of the carbon in Amazonia in a changing climate with so many influential variables that controls the carbon balance. And beneath all these things are the photosynthetic process that per se is a very, very complex system controlled by several enzymes who controls the front end of photosynthesis, and then we have loss of carbon by respiration, and this also involves not just the trees and the leaves, but as well as the soil per se, that is also a very important ingredient, like Davi has mentioned, the availability of phosphorus, but as well as all the microbiota in the soil that influence the respiration, that influences photosynthesis. So that's just a small example of the complexity that you have to deal when we are dealing with the carbon cycle in Amazonia. And more recently, a new challenge has showed up in the sense that Amazonia influences global climate change because of large emissions of greenhouse gases, but on the other side, the climate change per se, the increase in precipitation, as well as the increase in temperature and decrease in precipitation is influencing carbon uptake by Amazonia, and the importance of this is that Amazonia contains about 120 billion tons of carbon, and this is more or less equivalent of about 10 years of all fossil fuel burning the whole planet. So it's a huge amount of carbon that if part of it is released into the atmosphere, all the scenarios from IPCC that are not very friendly to us, let's say, will become really much worse than we see. And we are observing a lot of different changes in Amazonia, basically using remote sensing through a property that's called the vapor pressure deficit. We are already observing for deforested area, but as well as areas that has no deforestation in the northwestern part of Amazonia, an increase in the vapor pressure deficit that is indicative that something much more fundamental is changing the carbon cycle in Amazonia, because the emission by water vapor by the vegetation is tied to the uptake of CO2, because both process happens when a stomata of a plant open up to make photosynthesis, and then it loses water vapor to the atmosphere. So that's an indication of less water vapor being emitted by the vegetation, as well as a smaller uptake of carbon by the vegetation per se because of forest degradation. There are several papers with very different techniques that indicates this. This is one of them that mentioned that carbon loss from forest degradation already exceeds that from deforestation in the Brazilian Amazon. So we have to deal with two very complex and very different processes that are influencing the amount of carbon uptake and emissions from Amazonia, in addition to deforestation that we know pretty well is a big source of carbon. And one important point is that if you look for where the forest is having the biggest loss of carbon, this is not concentrated in the arc of deforestation, but actually very pristine regions from Amazonia are also being documented to lose carbon to the atmosphere. And another important indication of the link between carbon cycling and the global climate change is the issue not just with the precipitation, but with the temperature. So a paper published in Science shows that with a threshold of 32 degrees, basically the forest started to lose that ability to absorb carbon and started to becoming source of carbon. And very curiously, this is very different from Amazonia than from African forest, than from Southeast Asia forest. So that means what we are observing in Africa and in Borneo, for instance, does not apply directly to Amazonia, so you have to look specifically for issues that are particular for Amazonia. And in terms of future, IPCC have run several models, in this case 27 different models, where carbon cycling from the vegetation is coupled to the global climate. And what we observe is that Amazonia can become a big, can be a smaller carbon uptake response, where the forest can lose 1 kilogram of carbon per every square meter for every degree Celsius of increase in temperature. So basically, you see that the vulnerability of the tropical forest in Amazonia is larger than in Africa, larger than Southeast Asia. So basically, if you have to look into some region in terms of carbon losses to the atmosphere, that region should actually be Amazonia. And we see that from IPCC, we observe that the tropical regions, if you increase the global temperature by 1.5 degrees, as we are doing right now, 2 degrees, 3 or 4 degrees, you see that in terms of biodiversity loss, the most of the areas that will be impacted will be tropical areas like Amazonia, and Brazil have a lot of things to lose in this climate change scenario, and we have to understand that much better. So Davi also mentioned this very interesting and very important paper that was published in the cover of Nature a few months ago, showing that Amazonia can be close to a tipping point in, let's say, 10 to 15 years from now, where basically the changes in the ecosystem can be irreversible, and the ecosystem will start to enter a new state where it starts to lose carbon to the atmosphere at significant rates. So, and finally, another example is a recent paper from Marco Franco, from now in IAG, that done the job of attribution. Attribution is a big issue in terms of climate change. So basically, he tried to understand for every individual region in Amazonia, what is the responsibility of global climate change, as well as deforestation, in the changes in temperature and the changes in precipitation. So the result shows that global climate change is mostly responsible for the increase in temperature, but actually deforestation is the most important in terms of reducing precipitation. You see that even for the same ecosystem, you have very different drivers that both can influence the carbon balance. So it's a very, very complex picture. To address this complex picture, there is no way. You need a really complex data treatment, complex model, and then the challenges of big data in the geoscientific context are very, very high. There is a nice paper from Richenstein recently that shows the challenges that you have in terms of the velocity, in terms of speed of changes and so on, and how we could deal with these different aspects of data-driven science that we are dealing with the tropical forest per se. And we have many, many different challenges. One of them is the different spatial and temporal scales where some process actually mostly on a very, very leaf level space and a very, very fast process, while the other one takes an ecosystem or a global scale pattern. So we needed to actually deal with all these different scales, both in terms of observational data, that means in situ observation that are typically from a few meters or a few kilometers representation, to remote sensing observation that are mostly indirect. Let's always remember that satellite does not measure carbon flux, does not measure any DVI. What satellite measures is actually radiances, and then there is a model to convert this radiance in the property you want to use. So there is an important step in between these two different properties. And then in addition to the observation, we always needed to use models, and basically it's always important to remember that models are generally an approximate representation of reality, and most of the time is a poor representation of reality. So we needed to take into account that we don't know most of the process in this complex ecosystem such as Amazonia, the relationship between biodiversity and carbon cycling, between climate and carbon cycling, and so on. So basically, we also have important limitation in the models as well as important limitation in the data. And in terms of models, we have models that are basically process-based model, basically on physical, chemical, and biological process, or data-driven models that are becoming more and more sophisticated as we develop new algorithms that are able to extract information from gigantic amounts of data. And then now we are starting to combine both approaches, building up hybrid models where you combine data-driven together with the process-based models. And in theory, this can provide a much better understanding of what's going on in complex ecosystems like the ones we have in Amazonia. In particular, the land surface models are one of the class of these models, where, for instance, at the Institute of Physics, we use the JULIS UK model, but basically these models are becoming more and more sophisticated as science progresses, and we get a better understanding of actually what's going on in the land and atmosphere interface. So this is an example of a full complex land surface model. Of course, right now, because of computational constraints, it's impossible to integrate such sophisticated model in global climate models. They have a very, very limited parameterized component of these land surface models, and the global climate models, but this is improving very fast using machine learning algorithms. So basically we are doing mixed models between process-based and machine learning models that are actually the future of the global climate models. And the global climate models, as I mentioned, basically trying to resolve it for every individual grid cell for the whole planet, critical process controlling meteorology, biological, physical, and chemical process. And they are advancing very, very fast with advancing in computing power, as well as better data-driven algorithms that are improving these global models very, very significantly. On the other side, from the global models to downscaling, we are also progressing very significant where you can get, let's say, 150 kilometers global model grid to 5 kilometers grid over a single city or a single site like the Atoll site. So basically, this is improving also very significant with the new methods that are being able to, from the global, going to the local scale, much better than we could do, let's say, 3 or 5 years ago. And then, finally, the challenge of data integration. It's an enormous challenge for all of us, from the data engineering component to the people who collect this data in the field, people who construct algorithms from remote sensing to do a proper data integration per se. And then, basically, we are on the way to do much, much better integrated data sets where you can have land use and atmospheric variables like concentration of methane, concentration of CO2, precipitation, aerosols, radiation, integrated with the land use data like MAP biomass data. And I think that this is the future of the science in this particular area, and we see tremendous progress just in the last few years on this particular area. And then another area that's advancing significantly is the reanalysis data set, where basically you got modeling results, you reanalyze these integrated data simulation techniques, where you can have a much, much better view of what's going on in your ecosystem with these new reanalysis data sets that I think are also extremely useful and are promising very significant new visions of the very large data sets that are needed for Amazonia. Yeah, so the LEBA is running a large set of towers measuring flux. Some of the LEBA tower flux have 22 years of almost continuous data sets. So this has provided as a ground truth CO2 flux that is being extremely useful for us to understand that process I mentioned in the beginning in terms of what's going on, in terms of carbon balancing in the whole Amazonia. But the challenge is if you have 17 towers, how do you upscale the flux measurements in this tower for the whole basin? That is really what's really relevant, what we want to do. That's a challenge that we still have a long way to do, and I think that integration of data science with field measurement sites like Amazon Face, like LBA, like Atoll, like aircraft experiments we will do in the next 3 or 4 years in Amazonia, will provide a test lab for us to improve the science of Amazonian understanding of carbon cycling. And finally, also we need important progress in terms of atmospheric transport inversion models, where you get signals, isotopic or carbon flux signals from, let's say, the Atoll tower, and try to invert where that air masses come from, and where the process that from that air masses, from the emissions sometimes 300, 400 kilometers far from where it was observed to the observation. So these inversion models are also improving with the better resolution of climate models and transport models that I think is another important point that are clarifying several key properties of atmospheric transport of greenhouse gases. So basically, this is what I would like to bring to you, and we can discuss the future of this area soon. Thank you for the attention.
Guys, we have a break now. We come back in 3 p.m., okay?
William, o que você achar legal?
I'd like to introduce our next speaker. He's Michael Giansiracusa. Michael is a DevSecOps team lead at the Army Data Center, part of the Climate Change Science Institute, and the Energy and Environment Science Directorate. He holds a bachelor's degree in computer science with a minor in math. His experience includes research with USDA at the Carl Hazard Research Center in Tucson, Arizona, and internship with the Air Force Research Lab in Rome, New York, focused in machine learning and image analysis. Michael, feel free. It's all yours.
Thank you very much. Thank you, everyone. First, I want to start off by thanking Pedro and the University of Sao Paulo and all of you for having me here. It is an extreme honor, and I appreciate it very much. My talk is going to be significantly different than the last couple. We've been talking about basic science and data collection and research. My talk is more about data management, data curation, and data quality. I'm going to run through how the ARM Data Center does those different functions, some of the lessons that we've learned, and some of the things that are important going forward in the scope of data management, curation, and data quality. Oh. It's that button, right? Technical difficulties. Please stand by. Okay. Okay, thank you. Okay, so far, all of what we've been talking about starts with the data. We all want to get the data, and without that, none of this even matters, right? The research, the data management, the data lifecycle, all of it starts with the data. And so while most of what I talk about is going to be data lifecycle and data curation and data management, the whole focus comes back to data quality. It's all about supporting the process of ensuring data quality through data provenance, workflow provenance, and being able to track things as they run through your workflow. And this is all to support the need for open science. In the beginning of this talk, they mentioned that open science is one of the focuses of this. Making sure that our data supports reproducible science. And that kind of all comes back to data quality and data access as well. So starting off, this is a diagram of our data ingest process. Now, I know some of you have different styles and different challenges for data collection than ARM does. Much of our data comes in an automated fashion, and we have struggled over the years to automate as much of our data collection as possible. Now, there was a time when we had a sneaker net, as it were, right? We walked over there and got the data from the data logger and took it on a flash drive and put it in the computers where we then processed it and archived it. But we very quickly got to a point where that wasn't scalable. And so we automated as much of our data ingest as possible. So starting with our raw data, it comes in from our data sites. Now, Giri briefly talked about the variety of data sites that we have. We have several fixed stations all over the United States, in the southern Great Plains and in Alaska, but we also have mobile facilities that we deploy to locations around the world. The data within the United States comes in on dedicated pipelines, but for things that are in remote locations, we have to rely on either satellite or remote networks. And we have automated that process through a system of data gathering and our site data systems, which transmits the data from the site to the ARM data center in Oak Ridge. Now, right now, the pipeline flows through Argonne National Lab because of historical political reasons, but we're in the process of streamlining that. So that's an example of part of this iterative improvement process that we try to strive for. We are by no means perfect, but we try and keep making things better every day. So once our data comes in through our site data systems, we split the data into basically 3 different pipelines. One, where we gather metadata about the data that we just collected. Much of the initial setup for our data ingest process occurs as part of a collaboration with the scientists. When they submit an abstract for a new data product or a new data stream or a new research project, we define a lot of the metadata up front, and we gather metrics about what needs to be recorded to be able to reproduce the data and fix it later. One of those things is calibration data. Many of our data streams rely on calibration files to be ingested properly. They're not always correct. But because of the way we collect the data, it supports a data quality project as we go through our workflow, and then a reprocessing team later on, which can fix and identify and fix errors that we've seen. So once the data comes in, one arm of our ingest process is to gather the metadata needed to be able to categorize and make it accessible and fix it later. And the other is to validate its accuracy. Giri talked briefly about this one, and we'll get into this a little bit later. But we process data on a hour-by-hour basis. So we get data in, we process it, we gather quality metrics the same hour that it came in. We're creating netCDF files out of it, and that gives us the ability to provide that real-time data to some of our other facilities, like our SOND sounding balloons, which use that to determine whether or not it's safe to launch the balloons at the time. So once it's been validated, it goes and it gets archived in 3 different places. One of our core responsibilities as a data archive, and one of our tenets we have to abide by, is we have to have 3 copies of it for data provenance and to make sure that if anything happens to it, we haven't lost any data. And that's very important. Sometimes we'll have disruptions to these pipelines, but it gives us the leeway to be able to fix them at a leisurely pace rather than everything's on fire because we can't store our data. We know that we have multiple copies of it and we're saving every time. So once it comes in and it's been processed and it's been sent to the archive, we notify our processing cluster that files are ready to be processed, and this informs our data pipeline, which will support some of the data workflow that goes on next. So Giri mentioned that we use NetCDF files. And I think that we've been talking a little bit about data standardization as something that helps with automation. I've worked with data loggers in the past. I've worked with many different kinds. They output their own types of data files. They're in CSV, they're in tab separated, they're in a bunch of different formats. And many of you may have data that comes in proprietary or custom encodings. One of the ways that we ensure data interoperability is by putting it into NetCDF format. You can store all sorts of things in there, and it has high capability for data compression. NetCDF 4, which is the most recent standard, is built on an HDF5 support layer, which is very versatile and very efficient. Now, it's not always the best for every case. We're exploring other data formats, such as GeoTIFF and others, but right now, that's the standard that we have. And so all of our data gets stuck into NetCDF format. And one of the reasons we chose that is that they have a commitment to this backwards compatibility. Because we're such a long-standing project, 30 years, hopefully for 30 more at the very least, making sure that data is available for not just me and you, but the next generation of scientists is very important. And so we look forward to make it available through programs like the NetCDF project, which makes sure that even if we had data from 20 years ago that we stored in a different NetCDF format, it's still accessible by those modern workflows. So this is an example of our data processing workflow. Data comes in raw format. We process it into CF-compliant NetCDF. We use that standardized data format to create derived or downstream processes. Those downstream processes are one of the main ways that we engage with our community. People who want to submit abstracts for data stream, we call them data streams in ARM, but they're data products that for the level 2 ones, for the level 2 ones, we've added quality control variables. For the level 3 ones, those are the value-added products. And so maintaining this data pipeline allows us to do quality checks all along the way. And the quality control variables, which are embedded in the files, are added in the second level of processing. And so this here is an example of, unfortunately you can't see it, but this is, which one is this? This is the SOND instrument. This is one of our sounding balloons. So this one here is a sounding balloon. And we're able to generate this diagram because all of these relationships are in our database. This is metadata that we gather about the products and their inputs and outputs so that we can understand the relationships between our data and improve the pipelines. This one here at the end is an ARM best estimate value-added product that we create. One of our collaborative scientists uses multiple different input data streams and their associated data pipelines to be able to create this output product that many scientists find that one of our most useful products. And it's only possible because of the data, the metadata, and the data curation that happens along the way. All of this can be done within the ARM ecosystem, and it doesn't have to happen outside. So I mentioned earlier that the value-added products are part of the way that we communicate and we collaborate with our wider scientific community. Anyone can submit a proposal for a value-added product. And one of the things that we're trying to do going forward is to improve the support for community-driven products. The data interoperability that Gary mentioned, where we're talking about referencing data from different organizations in our data discovery portal, will eventually feed into this as well. Because we want to be able to create these derived products, these value-added products using anybody's data anywhere. This will facilitate science in multiple ways by allowing different organizations to collaborate with each other and to create products that have their own DOIs and are registered and accessible in an open and very clear way. So this is an example of our data discovery portal. So all of this is driven by the metadata that we gather by understanding the core components of the data products that we have and the products that we derive from those. So in this slide, we've got baseline VAPs, which are generated by researchers who are funded by ARM, but we also support external VAPs, which are proposed by anyone outside of ARM. And all of those are available through our archive and available through our data discovery portal. So one of the VAPs that we generate that's probably one of the most influential ones right now is our LASSO, which is our large eddy simulation model that is developed by a gentleman named Bill Gustafson. So this model, I think he has run it on 2 main sites right now, with Go Amazon being, I think, one of them. And all of the data that he uses to create his large eddy simulation model is in ARM. And so being inside ARM allows him to use our high-performance computing resources in a very streamlined way. He can order this data, have it staged directly onto our high-performance computing device, run his models using the Slurm queue, and then re-archive them into our archive without ever leaving the ARM infrastructure. Now, it would be nice to be able to expand that, to use other people's infrastructure as well, and to be able to collaborate, but it does make it very easy for him to do this kind of research. This is an example of the web page on data discovery that talks about the LASSO project. It couples ARM observations from field sites to provide that large eddy simulation model at very, very high resolution. Much of the metadata for this project actually changes from year to year because his models are always improving. This is the 4th year that he's been doing this, and every time the data gets bigger. So for instance, this last year, I think he generated 1.9 petabytes of data for one round of large eddy simulation models. It was the largest single archive job we've ever had. It was challenging, and one that I oversaw because we were transitioning to using a Globus-based archival infrastructure, which significantly facilitated archiving it at the time. So ARM provides quality control on 2 different main levels. So one is by an initial processing. When we gather the data from the scientific community and from the instruments that we have, we define, with the help of our scientific collaborators, logical boundaries that we're looking for in the files. So each NetCDF file has embedded quality control. For every variable in the file, there is an associated quality control variable. NetCDF files support something called data masking. So if we detect values that are outside the realm of possibility for an instrument, it does 2 things. In our initial data ingest process, it flags that data as bad and creates a data mask. So any of our users who download that data, the data for that specific flagged entry will be invisible to them, even when they read the file. You can unmask it if necessary, but it starts by being automatically masked because we've flagged it as bad. So this used to be a manual process, but it was one of the things that we automated first so that we could free up those people's time to do more impactful work. It's one of the ways that we provide quality control by default through automation. The QC flags are created in collaboration with the scientists who run those instruments. And so that's a little bit about our near real-time data quality. Gary mentioned that in his talk. That's how we enable that near real-time data quality. This is an example of that embedded quality control. So let's see. The temperature here has an associated QC temp, which is a data mask array, which will automatically mask that data for any user who downloads that data. The parameters used to define that masking are inside the quality control variable and are defined in the global attributes of the file. So this is another way that we enable quality control through self-describing data. You could download this file, and without ever talking to an ARM researcher, you could understand what is masked, why it was masked, and then how to understand what it means. Like, how do I unmask it, and how do I use that data? It allows our users to take calculated risks. Sometimes we flag data as indeterminate, sometimes we flag it as straight bad. And so it's a way that we inform the scientific community through automation. Another way that we engage with our scientific community is through our data quality problem report tool. This one is a platform that we use for the people who maintain our instruments to be able to talk to the data ingest team, the people who, in this case, would be on Pedro's team, who write the code that takes the data from the raw format to a NetCDF format. Sometimes there are inconsistencies between those, but we maintain a tool called the Data Quality Problem Report Tool, which allows them to have a conversation with all of the stakeholders in that data about what could be wrong. It allows them to do problem identification, reporting, and resolution with all the stakeholders in one place. Gathers everybody together, lets them have a conversation, and we resolve problems faster that way. And all of this is also defined in our database about who is responsible for which components of the workflow. So all of this is automated. When you open a quality control problem report for a specific instrument, in this case, the originator was Brandon Barton. He's one of our instrument mentors. This specific one was rejected. They thought they had a problem with an instrument. Through conversation with one of the ingest developers, they discovered it wasn't a problem, and they closed this one. But this is another one that he submitted where there was a problem. In this case, I don't remember exactly what this one was. I thought I was getting a different one. In one of ours, there was a cow chewing on one of the cables for our instrument, and we saw some interesting spikes, and they identified that that was bad, and our data quality system reported it, and notified the instrument mentor. They went out and looked at it, found bad cables, we replaced them. So this is one of the ways that we automate that conversation between all of our stakeholders. And it helps us automate as much of the interaction as possible. So that data quality problem report tool, if they've identified a problem that is not an instrument problem, it's a software problem, that moves into the ARM data center kind of sphere of influence, and they create data quality reports. Now, these are fully manual, at least at the moment. These require more complex resolution because they could be a problem with the calibration, they could be a problem with the ingest algorithm, they could be unresolvable because of extenuating factors. The data quality problem reports they are the second piece of our data quality infrastructure that supports notifying our users of problems with the data. The first one is that embedded quality control that's in each file. These reports are delivered with the data to our users when they order it. They span a specific amount of time. They either are incorrect or suspect, and sometimes they're resolvable and sometimes they're not. This is an example of their representation in our data discovery system. So each one of these different colored bars, the green is good data, routine and correct, or at least as far as we know. The blacked out parts are places where we have had data quality problem reports that have resulted in a report that says that this data is bad and either unrecoverable or it hasn't been fixed yet. Suspect, obviously, we don't know what's going on, it's indeterminate, and in this case, there's no limited access data. Those would usually be while we're testing a campaign and we're calibrating it. And so we notify our users through that system to be wary of pre-deployment data when we're testing it. This interface also provides a feature where you can view plots of the data that we generate during the initial ingest and processing algorithm. Oh, I forgot to mention, in that last one, when you order the data, we also have a feature where if a data quality report has been generated, we will deliver the data to you, but we offer you the ability to have it pre-filtered because the embedded quality control doesn't take into account these data quality reports. When we deliver the data to our users, they can specify that they want any incorrect data filtered out, and we update the mask for that file so that they don't see that data when they're doing their research. So this is an example of how we support fair practices in our data quality lifecycle. All of the data quality reports and instrumentation around how we implement data quality is accessible through a web service API. Anybody can go and access it. No keys necessary. You could hit it right now and get data quality or problem reports for any of our 3,000 plus data streams. It facilitates two different things. The first is transparency, but the second is it allows us to support automation in other workflows. This is an example of small improvements that we've made that have actually helped us automate other things that we didn't intend originally. Creating APIs that access these kinds of things for external users has been incredibly helpful in the long run. Oh, this is, okay. Data reprocessing. So we have a significantly large team at ARM that does nothing but reprocess our data. Any of those problems that have been identified in the data quality reports, if they have been identified as fixable due to calibration or algorithm errors or our data pipeline broke at one point and we got a data gap and we need to fill it. We have a team that goes back through and uses those data quality reports, identifies them, fixes them, and then through this user interface built on top of our database, once we resolve a data quality report, we no longer send it to the users because we consider that data to have been fixed because to the best of our ability, we have resolved the issue that was identified. This is the ideal solution for any of our data quality issues that we could hope for, right? We've identified an issue, we've done a root cause about why, and we've gone back and fixed it. Periodically, we do reprocessing jobs where we go and take a long-standing data stream from beginning to end, and we run the entire thing through our data pipeline. Even though we have all of the data already, it puts the data in a consistent format, which is helpful for data streams that we've had for 3 decades that may be in different formats over time. It becomes difficult for users to use, and so we periodically go back through and just reprocess all of it so that it's all in a consistent data format. We updated it to NetCDF4, and so that it's easy to use. Part of our reprocessing algorithm is capturing data provenance and versioning. So at the ARM data center, we never throw anything away. Every file we've ever generated, we have. If you used it to do data science for anything, we can give you that exact file that you used to do your research. If it had been updated by a reprocessing job, we will email you because we have a record of who downloaded every file we have. That's one of the ways that by gathering metadata and keeping it and holding on to it and running and making sure that data provenance is important, we can support open and reusable science. Anything that you've ever done with our data is reproducible because we have every single one that's ever been created. Okay, so this is coming to our data retrieval and distribution system. So this system supports what I just was talking about. Every order that's ever been placed through ARM, we have a list of the who placed it and every file they got and where we delivered it to. There is the data discovery UI, which is in the middle here. We have 2 different copies that you can order. One of them is on our fast online storage. The other one is in our deep tape archive. The 4th copy is at ANL, but it's not on this slide. And then we have an extraction algorithm, too. One of the extraction pieces is the data quality report filtering. We also offer metadata consolidation, file concatenation, and data conversion. We will convert the NetCDF files into a number of different formats, one of them being CSV, TSV, and there's a couple others that people have requested from us. And so when we pull the files out of the archive, we will convert them to the format of your choosing. And then at the end of that, we deliver it through FTP has been going on since the dawn of ARM. We've most recently added Globus and Jupyter Hub, where we stage it directly to our Jupyter cluster. So the Jupyter cluster is actually one of the things that I've been working on personally. I think it's a huge benefit to our data science community because it allows them to do some of this research and data exploration all within the ARM ecosystem. So our Jupyter Hub server is running inside ARM directly parallel with our archival system. So any data that you order can be immediately available on this Jupyter interface, which allows, we can talk to Felipe. I think he's going to mention something about this earlier. But this notebook that you're looking at, Felipe developed last winter as part of his internship with us. And we deliver this specific notebook with every order that has data that applies to this algorithm that he created. We hope to expand this capability to include classes, community-driven notebooks that provide visualization and processing support so that people who download ARM data can immediately start working with it without having to do any of the initial development that they may otherwise have had to do. In addition to enabling these notebooks to be delivered with our data orders, we also periodically run data workshops. So this one was one that we did last summer, not this most recent one, but the one before. This one was organized by a gentleman named Scott Collis, who is affiliated with an organization that does radar research and stores their data in the ARM archive. He frequently does outreach programs where he goes to colleges and runs workshops with their students to do coding challenges, teach them how to use ARM resources, ARM-developed packages, which we supply on our GitHub or GitLab instance, and then challenge them with a task, either do a visualization or do a processing. And then at the end of that, we make their entire algorithm that they developed available as part of a cohesive unit, a class, as it were. You could download these with all the associated data and notebooks from the data discovery site and it gives you a one-stop shop to be able to do some initial research or to understand the kinds of things that this workshop was targeting when they were working on it. This is one of the most influential things that I think we've had, because many people have talked about we're training a next generation of scientists, right? We're making the data available for not just our lifetime, but hopefully future generations. And having this ability to do these workshops within the ARM ecosystem in the Jupyter notebooks has been very useful, and we've had tremendously good feedback so far. So this is one of the things that having computing directly co-located with the data has enabled us to do in a big way. Let's see. Oh, this is an example of all of the different places that the students came from for the last ARM summer school. They came from all over the world. Well, not so much all over the world, but generally they were not all from the same city, right? They came all to, I think it was Ohio, to do this workshop. We ended up with 4 different class notebooks or class playbooks after this workshop. It was super fun. I was there for most of it. It was a great time. There was some struggling, but it was definitely very interesting. I think that this is the end, but I do want to mention something. One of the things that we do in addition to keeping data provenance on all of our data products and data pipelines is that all of our code, all of our repositories that we use to do data processing, they're all publicly available and version controlled. So at any given time, if we want to take raw data and reproduce a result that we got 10 years ago, we can do that. We're not just versioning data, we're versioning code, and we're versioning data pipelines. One of the things that I've been involved with these last few years is doing DevOps work, which is we now have a versioning system for our deployments as well. So as we deploy new workflows, we are keeping track of when we ran which workflows in the past and when we have updated them. And so we can say, if I need to fall back and go, let's say an algorithm that they developed a few years ago was updated and they realize it's bad, we can immediately fall back to the previous one and reprocess all the data from where we started using it up till now so that we can fix that data, right? Because reprocessing, none of us are perfect. We're collecting the best data we can at the time that we're given, but collecting the metrics, versioning our algorithms, versioning our configuration code, that enables us to go back and fix data so that we can ensure that it's the highest quality that we can possibly deliver to our users. So my dad was a Marine. He was a lieutenant colonel in the Marines. He was a pilot. I grew up around a lot of military personnel. I don't remember a time when my dad didn't make me make my bed. Every day for as long as I can remember. We've all had a long day, and so I wanted to leave you with an anecdote. The military is fond of anecdotes, and so I thought this was wild, right? Coming from a man who was otherwise a warrior and a leader, always making me make my bed. But the point of this is that you have to start with a good foundation. The data is the foundation, but gathering the appropriate data to be able to make that data discoverable, make that data identifiable, and make that data fixable when you realize that you've done something wrong is so important. And you can't do it later. You have to do it in the beginning. It's one of those foundational aspects of data management that has to be done in the beginning to make it effective in the long run. And so if there's one thing that my dad taught me, and this is of many anecdotes, this is the one I thought was appropriate here, we have to start with a good foundation. We have to start with a data management plan as early as we possibly can. We have to gather as much data about the data processing pipeline as we have, and that will enable us down the road to be able to fix the data and offer our users and future generations the best data we possibly can. That's all I have for today. I will dive more into the specifics of any of our data pipelines or our workflows or our tools tomorrow, or actually after this in the roundtable if you like. I'm happy to answer any questions that you have. Our workflows can be complex, to say the least, at times, but it was a decent overview. So thank you for your time.
Thank you, Michael. Nice presentation. So this is our second roundtable. I'd like to invite our speakers for this afternoon. Davila Pola. Michael, please, again. Paul Artachi is not here, but he's coming. Okay. Okay, well, keep it this way. Pedro, and I'd like to invite Raquel Albrecht from the IAG. Let's start with Amazon Face, actually. So this roundtable, we would like to discuss about the sharing data, the challenges, the perspective of the PIs of the programs, and see how we can learn with the ARM experience and FAIR data. So give us your perspective, what you are looking for the face, the Amazon Face, for the Atoll Tower Campinas, Campina site, and Go Amazon, and etc. What your expression about that? What you think about sharing your data? What you are about? This is the roundtable is. Okay? And Michael, give us your feedback about how to deal with all this data, actually.
Hi, everyone. I'm Rachel Albrecht. I'm a professor from here, University of São Paulo, but from the Institute of Astronomy, Geophysics, and Atmospheric Sciences. I work with Atoll Project with Paulo, Luciana, and many others. And we have been collecting like huge amounts of data at Atoll and also in adjacent site. It's a new site, which is called Atoll Campina. Campina is a reference for the vegetation of the area because we have the tall forest trees at the Atoll, nearby Atoll, but we have a transition vegetation from the river towards the terra firme, what we call the other vegetation type. So we have this site. It's not actually because of the vegetation. It is actually because of the vegetation, but because of the height. It is not too high. It is smaller because the intent of this site is remote sensing. So we have several remote sensing instrumentation looking upward to connect several variables from near surface all the way to the upper troposphere, and then connect everything that we are measuring at Atoll, which is up to 300 meters, to the rest of the atmosphere. And I have been working with the Amazon since I got into USP, actually, since undergrad. And so I have been passed through several field campaigns like Trim LBA campaign and more recently Go Amazon, which was like this whole new difference in data management from that we could learn how to do it good. But I have to be honest that I have been failing, like really, really failing. I was just mentioning with Luciana. because we are still in the process of, okay, we have the data organized, but it's organized in one PC. It is not organized everywhere. It is one PC. And we really struggle to have like even someone which is interested in the data to take care of that data and be like what we try to do is data mentor for each specific instrument. Even that is not working as well. But we really feel the need to make that really presentable, actually, to the rest of the community. Because right now it's an FTP site, just directories and go on. And the description of how we process the data, a few we have very detailed, but the others we don't. And it has, the data collection at this specific site started in 2020. So it's almost 5 years now. And as much as we protolate we don't start curating this, it will be a mess that we cannot recover. That's my feeling. And so GoAmazon, it was a really good example on how to do it. And I think like the whole idea of this workshop started with this interaction that we had with ARM during this project. And I feel that in this sense we had a good, how can I say, progress on this, because now we have data map, which is my hope that will actually solve at least a little, some of our problems. And we are really rushing now because we need to publish the data and actually make the scientific community aware of the site and the data that we have, which is actually free, because it comes from mostly from FAPESP funding. And we still are not comfortable of just putting like the FTP link that will probably fail in a few years. So.
I wouldn't feel too bad about that.
No,
we
I
still
do.
have an FTP link that has no authentication that we supply because several publications in the United States require an unauthenticated FTP location to gather the source data for any publication. So we still maintain one of those because they won't let us not do it. So despite all of our data curation, we still do that to this day. So I don't think that's so terrible.
Okay, is it on? What? No? Can you hear me? No? Yes. Okay. Let me correct something or clarify something I said in my talk, and taking the opportunity of what Raquel is saying here as well. It looks like it's our fault that our data is not organized, but it's not. It's not a fair comparison because if we look historically, you see all the work done by LBA that received the support from RNL. Historically, the GoAmazon that received the support of RNL as well to organize. We didn't internalize that knowledge in Brazil. We still need your support to organize this sort of data. We don't have such a facility and the level of expertise in terms of personnel internalized in Brazil. It's not up to us researchers, conducting the research in the front end to know all this. And it would be nice. In that way, the initiatives of Pedro of doing the data map, this is laudable. So it's going to help us a lot, but I have the feeling we are still miles away from where we should be in terms of infrastructure, the culture of organizing data, and having the expertise internalized in Brazil. So I'm not feeling bad that my data is completely disorganized.
Yeah, I wouldn't, honestly. One of the things that we struggle with at ARM, and I understand that we have a significant amount of resources that aren't available to every organization. We have long-term funding that supports this kind of data map style project that we can just provide to our scientific community as something for free. They don't pay us. The government pays us and the government pays them, and then they can just utilize our service for free. And I think that what Pedro is doing is going to be fantastic, because one of the things that we struggle with in ARM is actually getting the PIs to fill out the forms before they can archive their data with us. Like, they will wait till the last possible minute before the publication is going live to fill out the metadata forms to make that data visible on our data discovery portal. So I don't think it's anybody's fault. I think that the lesson to be learned here is to utilize programs like what Pedro is providing, like what we provide, like collaborate with these people who do have this more data curation, data management expertise. If it were up to our PIs, their data would be on a single machine, under their desk, in a closet, just like everybody else, right? We provide some of the structure, but we do it at a cost. You need to finish it before we can publish it, make it available on our FTP site. So I would say the lesson here is utilize the resources that Pedro is offering. Utilize us if you can, where possible, and we're happy to help. I mean, it furthers everybody's goal of doing open science and having better data if we all work together.
That's great, and I would just add, we need to build a culture of forming people that work with that. Because as far as I know, you are the single group in Brazil working with that in a more serious way and more connected to the type of science we do. It would be healthy to have more people, more groups working with that in Brazil, and I don't know how we do that. One step at a time. Right.
I have a question for Michael. Michael, I was talking with Davi about how many people we need to make the data valuable. So, you know, in the Army data set, we actually have a mentor for each equipment. So how to avoid that? You know, because you don't have enough people to be the mentor for each equipment. It's complicated.
I don't think there's a good answer for that. We don't have the available people to have a mentor for each instrument either. Some people mentor multiple instruments, especially our radar team. The people who mentor our radar instruments, radar specialists are hard to come by in general. There are just not many of them. And so our radar team is doing their best sometimes. I think that constant calibration is useful, but gathering those metrics about how your data is calibrated and how your data is gathered so that, I mentioned in the end of my talk, none of us are perfect. Like, if you went through our data quality or problem reports, if we weren't fixing them constantly, we would have thousands. The issue isn't that we're perfect. The issue is that we're gathering enough data to be able to fix it later, when we have time, when we have funding, when we have people. And so it's doing that kind of upfront work to be able to dig yourself out later, if necessary, if possible, right? But yeah, we don't have a mentor for every single instrument either. So doing that upfront work of having the management plan and having the recovery plan, I think, is the best thing any of us can do.
Thank you.
One thing that I see from, like, in the structure with ARM and like that we don't have here is that mentioning the mentors. I am from radar meteorology background, so I know Scott Collis and all those. And I know that they are scientists, and that they are also scientists funded by DOE to actually curate and work with the data and make the data usable. So maybe this is one thing that is missing. Like, I don't know if that is a line of funding or if FAPESP or any other funding agency wants us to, when we write the proposal to collect the data, and now we have the data management, but the data management, mostly it is how you will distribute the data and be archived, not processed, and make it usable for the next generation. And I think maybe what is missing is something like that, even in the own data management, and then putting resources on the proposals for that, only for that. I know, like, have the data map partially comes from all the Amazon data that we have been collecting, like the idea of trying to do this. But it shouldn't be only a separate proposal, like from Poly, but also a proposal within the same big ones. I don't know, maybe one way of doing our in-house working.
Yeah, nowadays, sorry, can you hear me? Yeah. Nowadays we have a lot of LLM algorithms working out there that they are training to deal with, like a ChatGPT, to deal with a specific task. I saw in the GRIA presentation that you are trying to apply AI in the Army repository, right? So how to think about create a chat, a bot, to deal with people that doesn't know how to code. For me, it's the problem. Usually the scientists and the younger ones doesn't like to code. So I think that you have some tools like a ChatGPT for Army data or something like that. We can help the people for no-code stuffs. Nowadays we have a no-code for everything. If you have a neural network, you don't need it to code. You just need to link boxes and make it work. So I think it's a good way to start. So what you're thinking about?
I actually have a lot to say about that. We tried that. ChatGPT is incredibly unreliable when it comes to code. It makes subtle mistakes that only someone who knows what they're doing can undo them. And that is just inherently not sustainable for things like making a no-code option. Giri talked this morning, oh gosh, it seems like forever. Giri talked this morning about the data workbench. One facet of the data workbench is a no-code visualization and processing algorithm that is just using the ARM metadata. We've got data streams, and we've got variables, and then we've got information about those variables. And so we are going to be able to provide those variables between a time series at a specific place and allow people the ability to create equations and process that data without ever having to write a single line of code. So for a no-code option, we found that to be more of a reliable way of doing that. They can visualize the data, they can process the data, but it's all built on top of metadata and file retrieval. The ways that we've used AI to augment our infrastructure is in data recommendation. We have a recommender algorithm that will create a profile of every person who's ever registered with ARM. It takes into account things like their ORC ID, their publication history, the data streams they've used from us before, and we'll make recommendations about classes and data streams that might interest them or facilitate their research in other ways. It'll recommend epochs for them that may help them study specific atmospheric phenomenon that may be of interest to them. As for more internally, something that we're working on is creating and this is something that I personally really like, but we are not there yet, is creating an ARM internal LLM, the large language model, that will act as a chat bot for onboarding new people, right? It'll have information about internals of ARM and how we run and our database schema and how our pipelines work and things. And so someone who comes and joins ARM, part of their onboarding process is reading through our documentation, but admittedly, it's not comprehensive. Like even we struggle in onboarding sometimes. And having a chatbot that understands our organization, we're hoping will help that kind of onboarding and understanding. But yeah, LLMs you do have to be careful with because they inherently will lie to you sometimes. So you have to put guardrails around them to make them safe.
Any questions from YouTube?
I had one for you. Actually, when you were showing the summer school and talking about it, I was immediately thinking, actually not, the Jupyter Notebook. I was immediately thinking, oh, could you bring to the notebook like external package? And on my head was PyArt. And then immediately you showed the summer school, which I assume is the Radar thing. So yes, you can do that, right?
Absolutely.
Okay.
Not just external packages too. Like you could download one that you created. If you put it out on a package repository somewhere, or even you can publish it to PyPI, or you can publish it to any language repository that there is. We're happy to build a environment specifically for your research if you want to do that. I've many times added libraries to our Jupyter Notebooks to support specific users' research. It helps a wider community in general. One of the things we just added was the R language support for the Jupyter Notebooks. I know there's some MATLAB Simulink users here. We are considering trying to add MATLAB support to our Jupyter Notebooks. We've got Julia support in there, and so this can be a multi-language coding environment that anyone can use. Like that's what our long-term goal is to have that kind of customizable workspace with the data and the tools that you're used to using so that you can do research using our compute resources as easy as possible, right? Just removing as many of the barriers to research as we can.
Pedro. Nosso coronel ali. Almirante, né?
Good afternoon. I'm a PhD candidate advised by Professor Pedro, and I have a question on renewable energy in your station. How do you handle the energy for your station? So you have 6 spots, I saw, and then you're going to need some electrical energy supply around. We deal with solar energy around Manaus in a project. How is that thing in your project?
Powered generators.
Oh, you burn fuel.
Yeah.
Oh, so
we would need to deforest 1 to 2 hectares to build a solar central.
Right.
To the demand, the energetic demand we would need there.
Yeah.
And we prospected connecting the phase site to the power grid that is 34 kilometers away.
Yeah.
It would be way too expensive to do that.
Yeah, kind of, right. What about to use solar energy?
Yeah, that's what I told you. We would have to cut 1 to 2 hectares of forest to put solar panels in the amount to fulfill the energetic demand we need there.
If you take the panels up.
We would shade the forest.
Oh, in somehow, yes, but you can think on an emergency energy, not to run the thing or eventually to reduce the CO2 burning from the generators. So it's a combined usage. I mean, a combined use.
Yeah, no, it would be great. We just didn't find nobody interested in investing in that.
Okay.
It's inexpensive.
I know. But the price, they are decreasing. And also there is some, I would say, energy politics in between, favoring solar in the Amazon forest. So we have a project, and if you don't mind, I will be grateful if you can share some details about that.
There are more serious talking about doing that
Okay.
in Atto, in fact,
Oh, yeah.
in the Campina side.
Yeah.
I don't know if you want to comment.
Actually, we came up with the same problem. We
Okay.
had to cut like a large area of forest, and then it wouldn't be ecological.
Right. But
sustainable.
if you want to run 100%, rather if you need some just emergency supply in order to avoid to I would say to erase data due to the power supply, I would say outage. So
We usually don't have too
Really?
many problems with
Oh.
that. We do have some outages, yes,
Okay, yeah.
because
Yeah,
yeah, can
it
the
happens.
generator failures and
Right.
everything. But with the no breaks, usually they
Yeah.
can do the job up to
Yeah,
now.
Yeah, that's the scenario we have investigated outside in other places on the Earth. And when you combine the solar, which is the best in this case, rather than, because there is no wind in the region you operate, you both, there is no wind at all.
There's
So-
wind way up high. But
Oh yeah, look, this is very expensive to get them in there. I agree, but in this case, what about to use solar as a way to, I would say, to take the wave about the renewables, energy, politics in the region, in order to avoid deforestation or something. Just to think about. Well,
No, yeah,
All right.
we looked at it. As he said, like Atto Campina was the first one that they thought it could have, but then on the project it was a large area, and we didn't get
enough money.
funding.
Yeah,
actually,
I see.
we tried one of the oil companies to fund.
Oh yeah, sure.
But yeah,
sure.
no, it was too expensive.
At that time, no, but today maybe, because.
No, this happened last year. So.
Oh, really? But we are going to see some change in politics. Yes, take your radar in I would say, longer range, because money may come. Okay, thanks.
Hi. So, Michael, I think this one is for you. Well, I was asking about the data. How could I, get the data from? I talked briefly with you about my experiments, ongoing and in future. So I guess that the answer to my question is, just to avoid me trouble, I go straight NetCDF. Is that right?
It depends a lot on what your end goal is. And I think Gary mentioned kind of as much. Like, I don't want to dictate how anybody else does their project. Part of our archive mentality is that we've chosen NetCDF. If you are a researcher and you decide to archive your data with us, we will convert it to NetCDF. We have a team of people who write ingests for code. They will work with you directly to take the raw data that you create and put it in a format that fits our data model. And then we will ask you for the necessary metadata to be able to complete that data model and make it available on data discovery in one of two ways. It's either a PI product, which has a flexible data model, or it's main data discovery, which has a very rigid data model. We have to get specific things so that it can comply with a lot of our FAIR principles, but we support both. But that's us, right? We don't actually expect our PIs to be doing that conversion. We just expect them to give us the data and the information to be able to do it for them, right? That's a service that we can provide, and we're happy to do it. And I'm hoping that Pedro and his team can do something similar. If it works for your situation, great. I was just looking up, actually, after we spoke. You can store images and videos in NetCDF format, but it's not recommended. TIFF format is a little bit better, but JPEG and PNGs and then MP4s are much more space efficient. So we generally don't have a limit on the amount of storage that we have, but I understand that that's a luxury, right? And many people don't have that. And so you would have to do something that fits your project goals and your project resources. So we like NetCDF. We're looking at TIFF files and GeoTIFF files as a future goal. But that would be my answer, is that if it works for you, that's great. And it does seem to work for us. So I would evaluate your requirements and your goals first. Does that answer your question?
Oh, yeah. I'm trying to process that. But for example, I'm not talking now about images, but like geo-referenced systems, if I have latitude, longitude, and some quantity, then NetCDF, right?
Yeah.
Way to go.
NetCDF provides backwards compatibility with previous models. It has a large supportive community. It has packages in almost every language that will read and process them. It has good compression. I would recommend it personally. It works for us. So,
thanks.
Yeah.
Last one. You talked about data management plan, or we're supposed to make some when we start some projects. So I'm not sure if my data management plan is a good data management plan. So any advice? Or a bad data management plan is better than no data management plan. So how is that?
Any advice? Ask someone. Collaborate with someone. The whole point of this thing is that we're collaborating together. I mean, we don't expect any one person to know everything. There's just too much to know. So I would recommend reaching out to someone like Pedro or his team or us, or there's plenty of other organizations that will help you. I mean, heck, you can talk to ChatGPT if you want. They'll probably help you out. But yeah, I would recommend talking to people. Collaboration is one of the most important and powerful resources that we have, and I think it's the reason we're here. We'd be happy to help, provide guidance or anything if you want to talk.
Sure. Thank you.
I'm going to Michael again. Michael, you said about that value-added plan, right?
Value-added products?
Products.
Yeah, it's derived data from our inputs, yeah.
Yeah, and is there any measurement? You said about the usability of these value-added products. How do you measure if the UX is being okay, if people is interacting properly, and so? Do you have any tool, any algorithm? I don't know.
I'm just going to restate it so I know that I'm hearing you correctly. You're asking how do we validate the quality and accuracy of those value-added products?
Yeah, and the use of it.
Okay. The value-added products are usually created by a specific scientist for their specific research. They're using ARM core data, our A and B level data, well, mostly B level data, and they're combining that data in ways that supports their research. I'm not an atmospheric scientist. But they're creating models, they're creating whatever kinds of equations they need to support their research and reorganizing the data in ways that supports their research. They provide us with the algorithm, and it goes through a review process. Experts from the scientific community review the data, and then we version the algorithm, publish it to our processing system, and then create output data, and then that goes through that versioning and review process, and then we make it publicly available. But sometimes, and actually frequently, those algorithms are updated. We often will update a value-added product algorithm and then rerun the entire thing throughout the course of our data because a new method or an updated method has been discovered.
Something like a software supply chain or, yeah?
Yeah, and that's part of the versioning of the algorithms, right? Every algorithm, every one of those, it's not up there anymore, but I had the RMBE best estimate product up there and the chain of processing that it goes through. Every single one of those processes and data products has a version associated with every change that's ever been done. And so many of the VAPs, the VAP processes, the algorithms that create those output products have many versions. And when we discover a new way or a better way, and I say we, I mean the scientists who created those value-added products. When they discover a better way to do it, they give us the new algorithm, we reprocess all the data, we give it to them to validate, it goes through that same validation process, and then we completely update the old data with the new data. We still save the old copy in case we need to fall back to it, but then we email everybody who's downloaded it in the last 5 years and say, hey, we've got a new version of this. It should be better than the last one. Please update
And
your research.
Is there any study about like software energy consumption or something like that in new softwares? And you
I understand that ARM is in a very unique position to not have the same budgetary constraints as many other organizations. We don't often have to think about those in the context of these reprocessing jobs. Yeah. And in fact, what we're struggle with more is using what we have. We have more compute power than we can sometimes shake a stick at. And so, please, hop on Jupyter. Use it as much as you can, please.
Okay.
It helps us by improving our metrics. So.
Okay. Thank you. Thank you very much.
Thank you. Don't want to invite with a lot of questions, but for Michael, and please, if you also please feel free to jump in if you can suggest around this idea. But if there is this national level agency or organization that has been collected information or data sets, particularly from different areas, named water, air pollution, social mobility, etc., very different areas for over the past years, but they haven't implemented yet a standard or a protocol to standardize all this data. What would you suggest as the first steps if they want to start organizing or implementing these workflows to organize the information, to standardize, but also to implement the necessary or the recommended automation processes so they can, when they gather new research or new data from the researchers, try to accommodate it or organize it in a better way? Do you have any first step suggestions? It's a little bit complicated, I know, but probably with your insights, they may have some ideas. Thank you.
May I? I think this one is not working. Is it? Yeah. First thing, find a data manager. And I think most of the projects in Brazil don't have it. They don't have one. I mean, it's something new. Data management is becoming clearly more important. It's entering the debate of scientific projects more and more now. So soon enough, I think we'll have to talk about how these agencies, the science funding agencies, will fund data managers for the projects or for a group of projects, let's say. And this is especially difficult. I don't know how this is in the US. Maybe you can comment, but we have a fierceful competition with the private sector here because the private sector pays way better than academic institutions here. So what is the carrot for IT people to stay with us and you know, develop this streamline the data management inside scientific projects? So I'm sure the others can contribute with other aspects, but in my case, find a data manager. And notice, I didn't say find a good data manager. Find a data manager would be already something, I think.
I agree, but yeah, we need to find, we have been trying, but as he said, we don't have any good carrots. So we have people that start with us, like at Atto, they work for 1-3 months, and this is just like filling a gap when he's transitioning, the person is transitioning from jobs, and then something better comes up and goes to the next private company. But yeah, because like we cannot do it all. We need someone to take care of it. Right now we do with students, but it's also not a good model for that.
We started by using students a lot. We started by using students a lot. Our entire data quality team used to be run by interns and students. So that's maybe not the best thing, but it's better than nothing. So your question was specifically about how to begin to standardize multidisciplinary data, right? You got data that's in a bunch of different formats and about a bunch of different topics and maybe not even related to each other, or at least not yet. If you're acting as a data manager, you're putting on my data manager hat, right? Look for international standards for that data. The closer you can come to international standards, the easier it will be to automate and find people who will help you with that, because the more people there will be that do that kind of thing. Anything that you have to do custom will be difficult to find people to maintain because there won't be as many people willing to do it or trained to do it. So look for international standards if you're trying to be a data manager of multidisciplinary data. If you're a data, well, I mean, I guess if you're collecting data from multidisciplines, I'm not sure who would do that, but like, let's say you are, I agree with this. Try and find someone who will help you with a data management plan who would end up doing what I just said for you, finding those international standards and then helping you implement them, because it'll be easier. It'll make everything easier as you go down the road, right? And then you brought up how to find and hire and maintain and retain data managers. That's hard. That's just hard. We have trouble with that too. I mean, Oak Ridge National Lab is able to offer job security and good benefits, and we still struggle with maintaining staff. It's just difficult. The private sector pays more in the US too. I mean, it just does. It's a hard thing to get around. So maybe start with students if you can, and see if you can go from there. I stay with ARM because I love it, right? I love the work. I love the fact that my job has meaning and purpose, and it's, I almost went and worked for the Air Force instead of ARM, doing LiDAR tracking systems. I morally objected to that personally, and so I'm glad that I was offered the alternative to work on something that I find more agreeable. That's why I stay. But I know that many people are motivated by money, and it's hard to get around. So.
The thing of using students, I understand the argument. I think many projects do that, but there's an associated problem there with continuity of things, right? Because after a few years, the student is gone, and if there's nobody replacing her or him.
We had that problem too. We
Yeah.
absolutely did. Our data
Yeah,
quality
but-
office.
Yeah, but we have tools nowadays to keep continuous their work. Of course, the students will pass. They have their own life. They have to get money. But we have GitHub, we have Zenodo, we have a lot of things that you can keep the codes forever. And this is the only way you have when you talk about students. They have to learn these tools first to use them. And if something is created, we'll be there. There are version that can be updated. So, but nowadays, it's only in the computer science team, we have people that really work with these tools. If you go to atmospheric science and the other things, usually the people don't use it. But we have the tools. But it's quite hard to learn about that.
Yes. I have a question. I don't know, sorry. Yes, I have a question to Davi and Michael. During your presentation, Davi, you told about the Amazon Face start the Amazon Face, I think 10 years ago, maybe, yes. And talking about the legacy data, how are you managing this legacy data? and what you have done with this legacy data is with, for example, this is about to distribute between the researchers, talking about this. And Michael, how do you work with the legacy data? For example, you have data collected 10 years ago. How you can manage this problem? Because it's not there's no more PI related with this data. It was a project that was finished 10 years ago. How you manage this problem? How you can work with this problem? So this is two questions for both. This is for both. Thank you.
Thank you, Pedro. I understand. Sorry, my ignorance here. The legacy data, you mean this long-term data?
The data that you start to collect, for example, because I know that you have collected, during my presentation I told for everyone, we have Amazon Face since 2022 or maybe something. And about the 10 years ago, for example, what you can, talking about what you have done related with this data and
that's the little bit of your presentation about Amazon Face that was not exactly correct. I mean, we started collecting data in 2015. 2015. The longest record data we have are meteorological data. And this is important for us because it will determine the amount of CO2 we're going to need in the experiment, especially wind speed, wind direction. So this is the sort of data we have the longest record in the site. And regarding your question, I mean, that's what happened. Let's focus specifically on this data. There were students, PhD, and especially postdocs coming and going and touching this data, improving it a little bit. Some improved it better, others you thought the person would improve it, but it remained more or less the same. And when someone needs this data, because it's a baseline data, everyone in the project needs weather or meteorological data. For example, a person measuring photosynthesis says, photosynthesis has dropped during this season. Why? Okay, let's compare it with the weather data, with the meteorological data. So everyone needs the meteorological data in the project. So every time someone needs this data, you have to ask, okay, who owns the data? Who has the data now? Okay, it's here, it's there. And that's what we are trying to solve, putting this data set in a single place, the most updated version with comments, metadata, and accessible. People can come and get it without having to pass through 3 layers of emails to different people. That's the much I... And the LBA data that we are very proud that was stored there at RNL, but this was the past data. If you need the more recent data of LBA, like I want to know the eddy flux measurements from last year, where is it? Nobody knows. and it's the same process. So, I mean, even projects that had that culture in the past, they lost it somehow, which is surprising, isn't it? Which comes back again to the point that we didn't internalize this knowledge here and the infrastructure and the expertise. But we are working on that. I'm sure we're going to improve, especially with your help. But that's the much I would comment, giving this example of the meteorological data, how important it is and how we are dealing with it and sharing or pseudo-sharing it. Maybe Michael can complement now.
dealing with legacy data is hard, and the turnover rate in organizations is difficult to deal with, especially if you're having them do human tasks. One of the ways that because we've experienced the same thing. We have old data sets that we have reprocessing jobs for, and the people who had the technical expertise to do that reprocessing aren't with us anymore. It becomes incredibly difficult to reverse engineer their algorithms, especially for complex jobs such as radar and LiDAR reprocessing. We have really struggled with that in the past. I have personally struggled with that, trying to do that. I would say having version control for everything you possibly can, and have students, when they are with you, develop automation where possible, like improvement algorithms that you have versioned. If they have a specific end deliverable, they either deliver it or not. If they don't, you throw it away. If they do, you can either use it or not, depending on if it improves your workflow or not. And then having the version control to be able to fall back if necessary. One of the things that we didn't do is we had some code in the past that used to be able to reprocess this radar data. It didn't get put in version control somehow. It either was in it and we didn't transfer it when we switched to GitLab from Subversion, different version control systems. It just didn't make the switch. And so the only thing we're left with is trying to reverse engineer it. And maybe we'll get a student someday to do that. Or maybe we'll have someone on staff who would want to do that. But it's an incredibly technical thing that a computer scientist like myself, I don't really stand a chance at doing it without understanding the radar technology. And so version control everything you possibly can and work on automation where possible, I think, is the best we can do. And I think we all struggle with that. So that's hard. That's a hard question to answer.
We have a question from YouTube, from Michael, of course. Michael, what's the issue of you working with LiDAR technology? It's a specific question.
Oh, no, this one was not to do with LiDAR. It was the fact that I would have, instead of working with ARM, I had the option of going to work for the Air Force Research Lab to develop target tracking systems using LiDAR radars. We track targets we're going to shoot at, and I was not I didn't feel great about doing that. I feel much better about working for ARM Data Center, facilitating climate science research and that. It has nothing to do with LiDAR in particular. It was the application that I had a problem with. And I'm not making a moral judgment about the military. I understand that's a whole different thing, and so that was just my personal take. So, does that answer the question? Oh, okay.
I have a question for you. You mentioned a few times that we should use your expertise, collaborate. You have, how can I say this? Not used computer power in Oak Ridge, but I mean, can someone just arrive there, especially from a different country, and say, hey, I want your working hours and your hardware for me?
Yes, we take open proposals for using our research. I mean, they have to be vetted and validated, but yeah. What country you're from, Brazil particularly, would not be a problem. There are some that are more difficult to get approval for, but as I think we're showing in this conference, one of the things that we focus on and we think is a benefit to all is when we collaborate, right? It improves everybody's life when we're able to work together. And so, yeah, I mean, I can find you.
I appreciate that very much, but there are some bureaucracies that I personally don't like, but sometimes we have to observe them, like when you need formal agreements between countries to do something like that, because sometimes there are sensitivities with data collected with public money in Brazil, that needs to stay in Brazil, be treated in Brazil, and that sort of thing. I don't know if it's
I can't recommend that you break the law. That's not what I'm asking. I'm saying that if we have some sort of, I know that we have a memorandum of understanding with the University of Sao Paulo and that data sensitivity is an issue. So if it will cause problems to try and use it on our infrastructure, I would not recommend doing that. But where possible, we're happy to collaborate.
On your side, it's not a problem. On the U.S. side and Oak Ridge side, it's not a problem. Is that right?
It depends.
Okay.
I can't say yes or no, but I can ask you to ask. The only thing we can say is no, but I would ask you to at least apply for access.
But
Yeah.
Michael, it's only if you use the data in the Army repository or not.
Generally, what we ask when you use ARM resources to do basic research is that you publish it back to ARM. And so that's one of the things. And so if there's sensitive data that you're not allowed to use, you're not allowed to give us, you wouldn't be able to use our resources because that's one of the requirements for it. Yeah.
Yeah, but Davi, we have the Santos Dumont computer. You just need to apply. It's quite easy. I told about the Santos Dumont supercomputer that in Brazil it's quite easy to use it for research, of course.
The problem is not only having a computer or a place to store things. We need people to do the dirty job.
This is another question.
Yeah. Oh, but that's what is involved here. It's not only hardware, but the expertise as well to advise and help organize things, right?
And I understand that using a supercomputer in general is hard. Like parallelizing code is a non-trivial task. Especially when you're talking about doing large matrix operations. I get it. That's not simple.
Try to use the Happiness from NVIDIA. It's free.
Well, one thing that we're starting to use that is helping, and I didn't get to demo it, but maybe I can tomorrow, is that we can show you how to set up a Jupyter Hub cluster. It's not super difficult. The way we have it set up so that it's automated, that's a little bit more difficult. But setting up one is not hard. And Jupyter has plugins. I personally am a Python programmer. I was a Java programmer for a long time, but now I do mostly Python stuff. Python has a package called Dask, which automates a lot of the distributed computing capabilities. I would recommend you at least look at that. Jupyter has a lot of integrations to make that simpler for you to use. A lot of the Dask implementation actually has plugins to run on Slurm, which is what it's the job scheduler that most HPC computers use these days, Slurm, so you can interface directly with that. So it can take away a lot of the complexity of using it. I mean, I'm happy to at least advise on those kinds of things.
But again, I think you shouldn't be talking that to him and myself, but to him. He would be the bridge, you know?
Duly noted.
No, we understand the concept behind, but we can never do it, like put our own hands and do it.
My wife, when she made a postdoc at the University of Tennessee, and she put with people there, but her data, she used the Titan.
Oh, she did?
Yeah.
Wow.
It was some bureaucracy.
That's awesome.
But that's okay.
But see, she was in the University of Tennessee.
We've worked with people there, but her data, she was here.
Okay.
Of course, they are.
No, but it worked in the past. I was just curious to know the formalities involved.
I just wanted to let you know.
Yeah, good. Thank you.
In one of these previous workshops, actually when Go Amazon was still fresh, I actually uploaded some of my data within the Go Amazon framework for Go Amazon. So it does work.
Yeah, I can't speak to the politics of it, but I would say it can't hurt you to ask. Like, you can ask for anything, just, the worst they can say is no.
The sensitivity I see, let me be clear here. For example, we have a project that is funded by Brazil Ministry of Science and the UK government, but all the data is stored in the US. How does that work?
Honestly, I don't know.
That's the thing. But I think this involves the politics and not the computational side of the thing. But it's something we have to take care as well.
I might ask this question to Giri when he's here, or tomorrow. He has a much more deeper understanding of the ways to get around those politics. Yeah, I'm more of the infrastructure back-end side.
Alan, you have more questions, or okay?
We don't have more questions in YouTube. Anyone in the audience would like to make some questions? Pedro, you can.
I think we can close the
Yeah,
section.
we can close
What do you
the
think?
section.
Yes.
Okay. I'd like to say thank you for all the
Thank you very much.
the people here in the road table, in the audience, our speakers, and Dr. Raquel or Rachel Albrecht to be here. Thank you so much.
So, thank you, Michael. This is, I would like to thank you for this section. This section about data curation is a very important, it's a hard question. Oops, is it working? Yeah, no. I try to use this.
Okay, better. This data curation is a hard discussion. Sorry for this discussion here, but it is very, very important, because you must take care of our data. You must train people how to do this. And these hard questions, well, of course, we would like to talk here about generative computing. Oh, how beautiful generative computing, how you can do everything. You just click a button, but it's not the normal life. The normal life is about how you can work with data quality. Data quality is a hard question, it's a hard problem that you must approach, because if you don't have good data, you don't have good results. So, this is thank you for approach this, the audience approach the discussion, and I hope you can continue to discussing this to find some good directions for this approach this problem, mainly here in Brazil, because you have another structure for approach this problem. It's completely different from US, but you must approach this problem. This is one important thing. And now, just talking a little bit what you have done here. We have a team, you are training a team. You are not just make data curation, but you are training students here. I think we have good fruits. You have good fruits about this. You have students that are training right now. And thanks to DataCite to provide this for us. We have a lot of students training about data curation. This is very important. And tomorrow, you are going to have a discussion about this, how you can approach this problem, how you can make data curation. For example, you have an instrument here that you collect the data, how you can make this data publishable. That's what we are going to discuss tomorrow, and the more practical way. You are going to show what you have done with some students here during the morning, and at the end of the morning for tomorrow, we are discussing about how you publish this data in that data map. During the afternoon, we are going to build some Jupyter Notebook, for example, just to show how you access the data in the army, for example, how you can make this data available, how you can access this data, how you can create a very nice visualization of this data. This is one thing that we are going to do tomorrow afternoon. So thank you for today. If you want to come here tomorrow, we'll be more practical, but it would be nice to understand better how you can manage this in the practical way. And everyone is invited. For today, thank you so much, guys. I hope to see you soon tomorrow, maybe. Thank you very much. Thank you.